to our YouTube channel Zero Analyst. This is the project 3 of our SQL 10 project series. In this video, we will create an end-to-end SQL data analysis project for a company called Zomato, which is a food delivery company. So this is an advanced SQL project. Now you can see the project name, which is comprehensive data analysis using SQL for a company called Zomato, which is a food delivery company in India. So first you will start setting up this database. So you can see we have multiple tables in this database, and this database, the concept that we will follow, which is Snowflake schemas. So you can see we have customer tables, we have restaurant table, we have orders table, we have deliveries table, and we have riders table. So in this customers table, we have the customers informations like customers ID, name, and the registration date. We have the restaurant table, which is the restaurant informations, and this is the main fact table that connect with all of this table. So this table has order ID, order informations, and this table has the customers ID. So based on this customers ID, we are connecting with the customers table, and this table has the restaurant ID. So based on the restaurant ID, we are connecting with this restaurant table. Now you can see this rider table has a connections with this deliveries table. So we just need to set up this database. Now let's see, after setting up this database, what are the tasks you will perform? Now let's see the concept that you will learn and the concept that you can showcase by doing this project. So the skills that you can showcase by doing this projects are going to be database creations and table design, which is going to be more about the designing a database. You will learn about the constraint like primary key, foreign key, not null, check, and other constraint. Then you will learn data retrieval and the data filtering, which is going to be the basic SQL syntax here. You will learn aggregations and grouping, which is having concept, which is here. Then you will learn multiple joins in SQL. That's going to be left join, inner join, maybe right join. And you will learn how to use window functions, row number, rank, dense rank, lead, leg to solve business problems. Then you will learn date and time functions in SQL. You will learn conditional logic. You will learn subqueries. You will learn ranking and order by. And then you will learn data segmentations, which is the case statement in SQL. Now let's see the different types of critical problem that you will solve by doing this project. By doing this project, you will solve 20 plus critical business problems using SQL. You will write complex SQL queries, which will showcase your problem solving skills, decision making skills, and the complex writing queries skills. Now these are the categories where you will solve problems. You will do customer behavioral and insight analysis. You will do order and sales analysis. You will do restaurant performance analysis. You will do rider efficiency and performance analysis, and you will do operational effectiveness analysis. So these are the category where you will solve 20 plus business problems. So without further delay, let's start the project. Now if you have not gone through the project 1 and project 2, you can check their link in the video description. In the project 1, we have done retail sales analysis. In the project 2, we have built library project management system. So you can check their link in the video descriptions. Hi everyone, if you're finding this content helpful and want to dive deeper, you can get your hand on this project by clicking the link in the video description. You can get your hand on this project by clicking the link in the video descriptions, which will take you to my TopMate account, from where you can grab this project for less than the price of a coffee. You'll get everything that you need to publish in this project. You'll get complete data set for all the tables. You'll get 20 plus critical business problems with the solutions. You'll get additional easily 20 questions which you can solve to enhance your SQL skills. You'll also get README file which you can use for publishing this project. You'll get editable PP to publish this project. And don't worry, if you get any issues related to anything, you can reach out to me. I will help you to publish this project. So without further delay, let's start the video. So let's start the video. Now let's explore the data set. So you can see we have this data set which is going to be customers. So this is one of the data set. Let's open this customer data set in Excel to explore the data. So I'm just going to make it 100, maybe 200 to view it. So you can see we have this customer's ID. We have customer name and their registration date, and total we have 33 customers in the data set. Now let's see other data set that we have. So let's see in the deliveries, we have delivery ID, we have order ID. In the deliveries table, we have delivery ID, we have order ID, we have delivery status, we have delivery time, we have a rider ID who has delivered the product. Now let's see another data which is going to be orders. So in this orders, this is our main fact table which has all the dimensions of all the different tables. So let's see the orders table. This orders table has order ID, customer ID, restaurant ID, order item informations. It has the order date, it has the order time, it has the order status, and it has the order total amount. Now let's see the restaurant data. So in the restaurant data, we have the restaurant ID, we have the restaurant name, we have the city, and we have their opening hours. Now let's see the riders table. So in the riders table, we have rider ID, rider name, and their sign up date. Now let me show you how you'll be publishing this project by end of this video. So by end of this video, if you follow along with me, you will publish the project like this. So you can see this is the GitHub repository where I have published this project. So we'll be publishing the project like this. You will write about the project overview, you will write about the main project structure, which is here. You will write about how to set up the database, you will write about how you have set up the database along with this code snip like this, and then you will write about the data cleaning that you will perform, and then you will solve 20 plus business problem which will include in the projects, and then you will publish these questions in this GitHub repository. So you can see this is the first question, this is the second question, this is the third question. Now this is based on my analysis and my findings. You may add more questions based on your analysis and your findings. So let's start. Now all this question that you can see, you can include in your project. You can also include additional questions based on your analysis and based on your findings. So let's first go to pgadmin 4 and let's create the database first. Now RDBMS I'm going to use is the Postgres SQL, and I'm going to use the tool called pgadmin 4. If you do not know how to set up pgadmin 4 and Postgres SQL in your machine, you can check my installations guide. You can check my installation guide video in the video descriptions. I will be adding a link. You can click that link, watch that video, and you can set up the Postgres SQL and pgadmin 4. Then you can continue the video. Now you can see I have launched my tool, which is pgadmin 4. You can use pgadmin 4 or you can use MySQL Workbench. So let's first set up the database. So first we need to create a database. So I will right click on it. Now you just need to make sure you're on the server and you see this on database, right? So you may have one server or two servers. So I have two servers. I'm going to use this server, and in this servers I'm going to use create. Now you may only have one server, so you just need to extend the server by clicking this icon, and then you can just go to this database. Once you click on this database, and you will just need to click on create database. So once you click on create a database, here you just need to give a database name. So I'm just going to give the database name called Zomato underscore db. So this is the name. You cannot use a space here, so you can use underscore. Now you don't have to touch anything else. I am just going to keep the by default user, which is going to be Postgres SQL. So I will just click on save. Now you can see this database is set up. So the database name is Zomato. If you don't see it, you just need to extend this, and then you will see the database, and you just need to refresh, right click and refresh on it. Then you will see the database name. So for us, the database name is Zomato db, which you can see it here. Now this is the empty database where we will create a different table. Then you will import the data set. So to launch the query tool, you just need to select this database, and you can just click on this query tool that you can see, or you can use this shortcut as well. You may have a different shortcut, so you can just go through the settings and check your shortcut. So once you are click and select this query tool, you will have this notepad where you will write your queries, and then you will just need to execute the queries by using this play icon, or you can use the shortcut. So you can see my shortcut which is showing as F5. So I'm just going to first change this shortcut to shift enter or maybe command enter. So to change the shortcut, you can just go to settings, and you just need to go to this display from here, and then you just need to go to this query tools, which is called this one. Let's go to keyboard shortcut, and here I can change the shortcut, right? So I will just need a shortcut called execute query, this one, which is showing as a shift, and I would just say shift and enter. So for me the shortcut is shift and enter, which is correct, but for you, you can change it. And if you want to change the theme, which is going to be from miscellaneous, you can just go to themes, and you can just change it to dark, light, whatever you want. Okay, so for now it's already set correctly. So let's write a comment. So here I'm going to write the project name. So it's going to be Zomato sales, Zomato data analysis. So we will create the database for the company called Zomato, which is a food delivery company in India, same as like Uber we have in abroad. So for the people who do not know about Zomato, Zomato is a food delivery company in India, same as like we have Uber food. So let's go ahead and first write a command which is called Zomato data analysis using SQL. Okay, so this is just a command. You can see I have just entered 2 dash, which you can just press command or slash, or you can just press control. So to comment any line of the code, you can just simply click on it, and you can just press command and oblique, or command and slash, or maybe for Windows you can just press control oblique or control slash. That is how the line get converted into code, or that get converted into SQL query. Hide all of this, and I'm just going to maximize it. So first we want to set up the database. So for that we will need to create the table, because at the moment the database we have, that is empty, that doesn't have any table. So let's first see the table that we will need, right? So let's go ahead and first create the table called customers. Now we will first need to create all the child table because the parent table will be dependent on this child table. So first we need to have this child table. So I'm going to first create this customer table. So let's go ahead and copy the column, and I'm going to say create table, and I'm going to name it called customers. So the column I want, I'm going to put it here. Okay, so let's go ahead and say, so I would need the column. I will put all this column here. So these are my 3 columns, you can see. So each column must be separated by comma. So I would just say comma, then I would just put the second columns, then again comma, I'm going to put the third column. Okay, so this is my 3 columns for the customers table. Now I will need to give their data types. So this customers ID column I'm going to set as a int. Okay, so I would set this customers ID as int, and I'm going to set it as a primary key. Now primary key will ensure that I cannot add any customers which doesn't have a customer ID. Okay, so that is a constraint. So that constraint is going to ensure that you cannot add any duplicate records, and you cannot add records where the customer's ID is null. Okay, so this is part of the constraint. Now I need the customer's name. So for the customer's name, I need to check what is the maximum character length of this name. So we already have this 32 customers at the moment, so we can check their length. So you can just double click on it, and you can check their length manually, or there is a functions in Excel. So if you're using Excel, you can just say max, and then in the bracket you just need to type len, and you just need to select this whole column, just close the parenthesis, and you will see maximum length, which is 15, but we can keep it at least 25, so that even if it is, but we should keep some extra character, because if there is any customer who has longer name, so that is still going to valid our database. I will say varchar and 25. So varchar is a data types in SQL, which you can use varchar, same as like string we have in Python, right? So here next we have, which is the registration date. Now if you see the registration date of this table, so this column has a date type data, right? So you can see the data here. So this seems to be a date type data, so I'm going to select is as a date. Okay, so my first table is done. Now I am going to create the second table. So let's first kind of move it 1 indentations to the right. So this is my first table. Let's create the second table. Now for the second table, let's see what is the second child table we have. So customers is a child table. Now this restaurant is a child table, and this riders, these 3 tables are child table. Then you have this order table, that is our one of the fact table, which has all these orders informations, and also that has a customer's ID, that has a restaurant ID, and that has this deliveries ID. And then this delivery table will have this rider informations. So let's create our second child table, which is going to be this restaurant table. So let's see the column that we have in the restaurant table. So I will just make it 200 to see the details, and I will need all these 4 columns, right? So I'm just going to call, now I'm just going to create table called create table restaurant restaurants. Okay, now the column I need nothing but what I have copied from this Excel file. Okay, so let's give comma, let's give comma for the restaurant name, let's give comma for the city, let's give comma for this opening hours. Okay, so these are the column I need, and I will just put them in next line. So for the restaurant ID, again the data types are going to be int, and it's going to be primary key. That means we cannot add any restaurant without this key, right? Without this restaurant ID, because this is the uniquely identifier, right? So we will need to keep it as a primary key to maintain the data integrity. So next we have the restaurant name. So the restaurant name is going to be again varchar, because you can see the names are text. Now here we just need to check the maximum length, because the restaurant name can be larger. So we will again use the same function, which is called max, and I would just say max and then len, which is going to be max len, and I will just select the entire name, double parenthesis close, and we can see 28. Now I'm going to keep it called varchar 35 or maybe 55. Okay, so even if in case we have the restaurant with new restaurant coming up with a larger name, so still this will be valid, right? This data types. Now for the city, we will check the data types. That's going to be city, which is a short data. Now we can just again check it by simply saying max, and we can say len, and we can just select this column and close this brackets. So that's a 9. So again I'm going to keep it like maybe 25 or maybe 15. Okay, so that's fine. and this opening hours, again for this one, this is going to be text data. So though you can see you have the data in the time slots, but this is a text data. So for this we will again check with max, and we will check len, and I will just select the whole data set, close the brackets. Seems like 38, so I'm going to use it varchar 55 to ensure that if there any record that has a larger character length, that is still going to work. Okay, so this is my restaurant table. Now let's set up the next table. Now let's see what will be our next table. So we have customers, we have the restaurants, then we will have the orders, right? To have the orders, let's see what are the things we will need, right? So you see in the order table we have order id, we have customers id and restaurant id, which we will get from the restaurant table. Then we have order item, and we have order date, order time, order status, and the order amount. So that means this order tables depend on this customer table for getting this customer's id, and in the restaurant table getting this restaurant id. So these two columns are going to be foreign key, because based on this customer id we can get the customer information, based on this restaurant id we can get the restaurant informations. So we will go ahead and create this table, because our both the child tables are ready now. So let's go ahead and create our next table, which is called create table, and this table name is called orders. Now I will need the column which are mentioned below, so I would say all the columns here. Let's kind of keep one line space, and let's say the columns that I need, which is going to be customer, which is going to be order id, restaurant id, order item, order date, and this order time, and order status, and the total amount. Okay, so let's go ahead and kind of create all this column. So order id is going to be int, and primary key, again the same conditions, primary key, ensure that no duplicates and ensuring that no null values. Customers id is int, so this is coming from the customer table. Now I can just write some comments called this is coming from customer table. Okay, now restaurant id, again this is going to be int. Now this is coming from this is coming from restaurant table, right? So this is coming from restaurants table. Now these are just a comments, which just to ensure that I remember like where these columns are coming from in the database. Now you see order id, which is order item. Now these are going to be text like the order product name. So let's quickly check in this. So we have order id, we have customers id and restaurant id, then we have this order item. So here we need to check the limit, because these are the dishes name, so they may have the longer text. So we will again use max length functions, that's going to give us the maximum count of this all the order item name. So let's kind of close it, and we see 24. Now you see this order table has a really large data set which has a 10,000 records, so we can use this max function which is very useful, and that returns the maximum length from one of the column. Okay, if you cannot access the file in Excels, you can use Python script length functions, which you will get the same informations. So we will say order item, and I'm going to say varchar, and here I'm going to again use varchar 55. So we have maximum 38, but I will just keep some extra varchar. Now for the date, it's going to be date data types, and for the order time, it's going to be time data types, and for the order status, I will just need to check. So let's see for the order status. So for the order status, this seems to be a varchar which is not longer than 25, so I'm just going to keep it called varchar but 25. Okay, all the column must be distinguished with this comma as a delimiter, so I will just say comma, and this total amount, I'm just going to check that. So this total amount is this total amount, so this amount can have float number as well, so I will just keep it float, or you can keep it int as well, so I'm just going to keep it float. So this is my third table, which is the order table, that is going to create a order table, right? Now next what we need is the next table. So next table that I need is going to be nothing but the riders table and this deliveries table. So for the deliveries table, that will depend on the riders table. If you check the data, you see this delivery table need a delivery ID, which will be created automatically. Then we need order ID, which we will get from the order table, which is already created. Then we need this delivery status table, you can see it here. Then we have this delivery time and this rider ID, like which rider has delivered. That means this rider table would be one of the child table for this table. this order table would be one of the child table, and this is going to be our second fact table. Okay, so we will create this table with all of this column, but before that we need to create the rider table. So let's go ahead and copy the rider table name, and then we will create a rider table before creating the deliveries table. So I would say create table, and I'm going to name it called riders, and the column I need are going to be this, which is a rider name. Rider ID is going to be int and primary key. Okay, then rider name is going to be varchar, which is going to be maybe 55 is going to be fine. Okay, I'm sure this length is going to be less than this. So sign up, this is going to be date. Okay, because I've checked the data types. Now the rider table is set up. Then we can just have our next table, that's going to be last table, that's the deliveries table, because the deliveries tables need all this information like this delivery ID, order ID, which will come from the order table. So the order table must be created, then only we can create this delivery table. Then we will need the rider table, because the rider table is also one of the child table. So I would say now create table, and I'm just going to name it called deliveries, and the column I need are going to be, these are the columns. Oops, let me just copy the column name. So these are the column I need. Okay, now one is delivery ID, so let's go ahead and kind of put it little up. So we have delivery ID, that's going to be int data types. Then I have this order ID, that's going to be again int. Now then I have this delivery status, that's going to be varchar. So varchar, I'm just going to copy the delivery status from here. So varchar 20, oops, varchar, and it's going to be 35. You can again check the limit using maxlen function in Excel, but I think 35 is going to work fine. Now delivery time, this is important, this is going to be time data types. So we can check that in Excel's delivery order rider ID, that's going to be int, right? So here you can see this which is called order ID, that is coming from, this is coming from order table, right? Orders table. And if you see this rider, which is this one, this rider ID, this is coming from one of the child table, that's called riders, right? So before creating this deliveries table, we will need to have this rider table. Okay, then only we can create this deliveries table. And here this delivery ID is going to be primary key. That means you cannot add any records, any delivery records without this delivery ID, or this delivery ID as null or duplicates. Okay, so this is fine. Now let's execute this query. Now this is going to be a transactions, because first this table is going to create it, then this table is going to be created, then this table is going to be created, right? Then this table is going to be created, and then this table is going to be created. So we will create 5 tables. I have not yet defined any relationship between them. I have just added some comments. Okay, just to show you, let's first create this table. You can just click anywhere and you can just click on this play icon, and you will see this query return successful. That means the database is set up. Now we can just click on the database, and we can just check our database, all the tables. So just click on refresh and go to the schemas from this and database. So you need to go to database, then from this public go to this schemas, and from the schemas you will see this tables. Okay, so let me just show it again. So you just need to go to this in database. Now in the database, right click and refresh it. So then click on this extend icon, and then from here you go to the schemas that you see it here, and from the schemas go to public, from the publics go to tables. So here you can see all the tables. If you don't see it, again right click and refresh it. Now you see we have all the 5 tables. Now we can generate a ERD, which is called entity relationship diagram, that is going to give us the structure of the database. So we still have not imported any database, but we can see the database structure, like how many columns are there, how many tables are there, and how they are connected with each other, right? What is the relation between each table? So to do that, you just need to right click on the database and then click on ERD for the database, which is this options. Now that is going to create a ERD. Now if you see the, now if you see the example earlier which you have checked, we are expecting ERD something like this, okay, where we will have the relationship between each other. Now if you see this ERD that it has generated, it doesn't have any relationship between them, because it has just created the table. So we have customer table, but you can see there is no relation between customers with deliveries, and we do not have any relationship with customers with orders. We do not have any relationship with customers with a restaurant, and we do not have any relations with deliveries, and this delivery doesn't have any relationship with riders. The reason is that we have not defined foreign key constraint. We have just defined primary key. Now if you see here, each table has a primary key, which is great. So that will ensure that we cannot import any null or duplicates a record in the table. So now here you can see this is one of our child table, this customer's table. This customer ID is a primary key. That's the reason you see yellow key here. In the restaurant table, you can see this restaurant ID is the primary key, yellow key. In the order table, order ID is the primary key. In the delivery table, this delivery ID is a primary key, and this rider table, rider is the primary key. Now here we will need to connect this customer's ID and this customer's ID. So this customer's ID here, it is going to be a foreign key. And to become a foreign key, that column must be a primary key in its own table. That means in the child table, that column must be a primary key, then only that can come foreign key here. Okay, so same ways we will need to define restaurant ID as a foreign key. Here you see here restaurant ID will be as a foreign key. Now to become this restaurant ID as a foreign key here, restaurant ID must be a primary key here. Okay, now what will happen if you try to add a records where you will say try to add a orders and details, and it is going to ask you the customer's ID. So you cannot create an order without adding the customer's ID. Now when you will add a customer's ID, let's say 125, that customer must exist in this table. That means as this customer's ID 125 is coming from this table, so that customer's ID 125 must present in this table. So SQL is going to check if this customer exists in the customer table or not. If that customer's ID doesn't exist in the customer table, you will not be able to create a orders. So that means it's like if in case there is a no customers by 125, how you are creating a orders, right? So that integrity it is going to follow, right? So here this deliveries table that need a order ID. So that means if in case you are trying to create a delivery records, so that will first need a order ID. If in case you don't have a order ID, you cannot create a delivery, right? So for this delivery table, it also need a rider, right? So who's going to deliver that product? So that is where we will need this riders. So we'll need to build this relation. Now you can define this relation while creating the tables. Let's say if you have not defined while creating the table, you can use the alter command to edit later on. So what I can do here is that we can use alter commands after this orders. So here we can use alter commands. So let's say here I can use alter commands, okay, to add some constraint, adding fk constraint. Okay, we'll use alter command to add a constraint. So let's see how we can use alter commands to add constraint. So first constraint we want to add in this customer's ID of this order table. So the syntax is very simple. You just need to say alter table. Now which table? It's going to be orders table. Now what thing you would want to do? So we want to add constraint. So I'm going to say add constraint. And what constraint? What is the constraint you want to add? You can just give a name here. So I usually give something like this fk, and I would say it's coming from customers. So this is just a name. You can give any name. So if in case you want to delete it or you want to drop it, you can use this name. Okay, now what constraint you are adding? So you need to define that, right? So here we would say foreign key constraint. Okay, now on this column, on which column you are adding this foreign key of this table? So I will say that this column, which is customers ID. So whatever the column name, you must put that column name inside these brackets. Now here I would need to say from where this column is coming, right? So to become a foreign key, that column must be a primary key in another table, right? So this column we know that it's coming from the customers table, right, which is here. So I'm going to say customer table of customers ID. So you need to write something called references, and you can say customers table of customer ID. So make sure the spelling is correct. In the customer table, customers ID must exist, or if it is a ID in the customer table, you can just write ID. Okay, so this is going to create a relationship between this orders and this customer based on this customer's ID. I can just run it. You can see it has created. If you want to verify it, you can just go to this orders table, and inside this order table you will have this constraint. Now you can see fk customers constraint. So this is the constraint we have created. By default, orders pk, which is the primary key of the order table, is a constraint. Okay, now we need one more constraint. So let's see the second constraint that we need. Okay, the second constraint we need on this column, which is called restaurant ID. So we can add it here. So to add a second constraint, we will just copy paste the same, and I'm going to use order table, and the name that's going to be fk, and that's going to be for restaurant Okay, now which columns? So here we need this restaurant ID, so I'm just going to say restaurant ID. Now from where it is coming? So that's coming from the restaurants table. So in the restaurant table, restaurant ID must exist, right? So if you want to check, you can go to restaurant table and you can see this restaurant ID exists and it's a primary key. So these two conditions must be fulfilled, right? Then only you can add the constraint, right? So this is how it has created the second constraint. We can just refresh it and you will see this third constraint here, which is FK customers, FK restaurant. So two constraints are done. Now in this table, which is the delivery table, we can add the constraint. Now we have seen how to add the constraint while creating the, after creating the table. Now I'm going to show you how you can add constraint while creating the table. Suppose we are creating this a delivery table again, and we will try to add the constraint inside while creating the table. Okay, so you can just write it called drop table if exist. Now what is the table name? That's going to be deliveries. You can write this, it's going to delete the deliveries table. We can just verify it. Okay, so you can see this delivery table is gone because the delivery tables, it depends on the rider table. That's the reason you can delete this deliveries table. Okay, but once you build the relation, you cannot delete this rider table, because this rider table will be, this delivery table will be dependent on this rider table. So first you need to delete the parent table, which is going to be delivery table, then you can delete this rider table. So now let's say I'm creating this table again and I'm going to define the constraint. Now as like primary key, you define it here, right? After the columns and data types, you define it here. But for the constraint, which is foreign key, you cannot define after the column data type. So what you can do, you can, after the last column, you can define it here. You can just give a comma and then you can say constraint. Okay, constraint, then you can just give a constraint name. The syntax will be same as well. So this is going to be the order ID. So we are adding something called FK orders table. Okay, that's just a name. You can give any name or you can skip that as well. So I'm just saying, hey, constraint FK orders. Now what constraint? It's going to ask a constraint. So that's going to be, again, the constraint is foreign key. So I would say foreign key, and it's going to say, hey, okay, foreign key. So on which column? So I would say on this order ID, because this order ID is coming from the order table. Okay, so fine. Then it's going to say references. So references, then here I need to define it, right? Orders table of order ID. So the column name must be same, and this order ID must be primary key in the orders table, which is already correct. You can see the order table and this is a primary key, so that can be a foreign key in this table, which is the deliveries table. Okay, so that's one of the constraint. Now we need one more constraint, so you can just give comma. So then you can add the second constraint. Now second constraint we want to add for this rider. So I'm just going to copy paste this here and I'll just delete extra comma. Now it's a constraint, and I would say FK of riders. Now this is how I give name, so that is easy for me to remember. Like I'm saying fk.riders, that means this constraint is coming from the rider table. So I would say, what is the column name? So the column name is going to be rider ID. So I would put it here. References is going to be riders. In the riders table, it's a rider ID. So we can just check. Yes, it's a rider ID. So we just need to put the right column name. Now let's go ahead and kind of execute this. So it's going to create a new column and it's going to build the relationship. Okay, now we can just right click and refresh it. Now you can see we have new table, which is called deliveries table. So we can go ahead and right click and click on create ERD, which is this one. So this time we will have the ERD with a relationship. Now you can see we have the ERD with a relationship. So let's organize the data set. So first we need customers, which is here. We can see it here. Now then we will need a restaurant. So I'm just going to add the restaurant maybe here. And then I will need riders here. And I'm going to say orders. So orders, I will just put it here. Okay. And I would say riders I need here. So I need deliveries here, because the riders is dependent on this delivery. This delivery is dependent on this order. And this orders is dependent on the customers and the restaurant, right? So you can just spend some time to kind of format it. So if you just click on this corner, it will just give you options to kind of organize it. So let's go ahead and spend some time. Okay, so this is done. Let's go ahead and kind of spend some time on this one as well. So this is like little funny. It takes some time for you to kind of organize it. Okay, so here one thing I want to explain. You can see something called this one to many. Okay, now if you want to understand this one to many, this is called cardinality. Now this one to many, that means one customer that can have one record in this table, but that same customer can have multiple orders, right? That means one to many. If you see this, one restaurant will have only one records in this table, which is the restaurant table, because the restaurant ID is the PK, right? It cannot have a duplicates. But one restaurant can have multiple orders, and that means in this restaurant ID we can have the same restaurant ID multiple for multiple records, right? Because the restaurant can receive multiple orders. That's what we call one to many relationship. Now this is done. Now let's kind of do some formatting for this as well. So I'm just going to kind of again drag it maybe here. So we just need to kind of play with it, and so this seems to be fine, nicely organized. So you will just need to spend some time. Okay, so this usually takes some time for doing this formatting. Okay, I think this fine for me. And next what I need is this, which is going to be my next table, that's the writers. So let's kind of do some formatting. Okay, so this seems to be fine now. Okay, now let's see the rider table. So here rider table, I'm just going to build some relationship. So rider table, and let's kind of make it a little big. So this usually takes some time, as I said. So this is fine. Now I can see the database same is set up. I can just take a screenshot using my shortcut, and I can include this in the project in GitHub repository. So this is the ERD that we have created. Now let's do some basic analysis, and we have set up the database, right? So the best practice would be this in drop commands. I can just write on the top. So I would first say drop table, drop table, drop table, drop table, drop table. If in case I need to delete one of the tables, so I will just write all this in drop commands here. Okay, so drop table, first I'm going to write call this orders, because the orders dependence on this customers. So then I would write this customers. Okay, then I would write this restaurant. Okay, and then I would write for riders, then I would write for deliveries, and I think these are the 5 tables we have, right? So this is how we write the drop commands. So we can just run this. Is going to delete everything. Okay, so for now I think this is good to go. So I'm just going to say end of schemas. Okay, now this ERD that we have created, this is very useful for solving any problems. You will need to refer to this ERD, because by looking to this ERD you will understand that okay, what join we need to do and how each tables are connected with another table. Then you can build your logic to solve the business problem. Okay, now let's go ahead and see all the business problems so that we can solve one by one each of the business problem. So I'm just going to copy all the business problem here. Okay, maybe in the next node query tool. So I'm just going to first of all save this schemas. Okay, so to save it, you just need to click on the save icon, and then you can just create a new folders wherever you want to save it. So I would say Zomato 2, and here I would say schemas. Okay, I'm just saving it as a schemas. Now next what I want is going to be all the loading all the question, right? So the business problem that we will solve based on this data set. So first let's explore the data. So I'm going to launch a new query tool. So to launch a new query tool, you just need to select your database again, and then click on this query tool, and that's going to launch your new query tool. Here you can say that exploring, or you can say EDA. So we will explore the data, right? So let's first see each table and what is the data that we have, right? At the moment we have not imported the data. First we need to import the data. Now the table we have, which is called customers. Okay, so I would say select everything, which is select start from customers. So that is one of my table, and then I would have the second table, which is called restaurant. So let's say restaurants is my second table. Then I have the next table, that's going to be the orders. So let's see the orders table. Then I have the next table, that's going to be riders. Let's see the riders table, and then we have deliveries. Okay, deliveries table. So these are the 5 table we have at the moment. In the customers we don't have anything. You can just run this query. In the restaurant also we don't have anything. In the orders also we don't have anything. In the riders also we don't have anything. In the deliveries table as well we don't have anything, right? but you can see the table structure, right? Table columns and the data types, you can see it here. So let's go ahead and import the data. So I would just write call import data sets, right? Now we have different tables. We need to import the data to their respective tables, right, based on the column and the data types. So let's see how we should import the data. Before continuing the video, I would request you to subscribe to my YouTube channel if you have not subscribed yet, and you can hit the like button and you can comment with all of your doubts in the comment box. So let's see how we can import the data. So I will first need to go to my database and schemas, then I will need to find this table. So I will just click on these tables and refresh to kind of get the latest tables. So first I would right click on this customers, click on this import and export, and from here I need to click on this import and I need to go to options and make sure this header is enabled. So by default it would be disabled. I need to make sure this enable because our data has a header. Rest everything will remain same. In the general I will just need to select my path, right? So I would click on this folder icon, go to desktop where I have the files. I would go to Zomato project, go to dataset, and from here I would select the customers because I'm importing two customers, right? So let's go ahead and press OK. Now you will get two green check. One is the process started and one is process completed. These are the two green check you can see. Now we can just execute this, select everything from customers. That is going to give us all the customers. You can see we have 33 customers at the moment. Now let's go ahead and import into restaurant. Now we need to maintain this orders, right? So we first can import to this child table, then only you can import to the parent table, then you can import to the child table, then you can import to the parent table. You cannot import to the parent table because if you're trying to insert orders and that order cannot find the customers and the restaurant ID, so that is going to throw in error. So you need to follow this hierarchy, okay? So first import to customer, then import to restaurant, then orders, then riders, and then deliveries. So let's go ahead and import next to restaurant. So right click, import, select the restaurant data set. That's going to be restaurant, and from the options header is enabled, so everything remains same. So you can see process started, process completed. That means the data set is completely imported. So let's run this query. You can see the data set, we have 71 restaurants so far. Now let's go ahead and import to the orders, which is the largest data set. Now to import, you can just say right click and you can see import, make sure header is enabled, and select the right path. So that's going to be orders, open, click on OK. Now if you can see to process completed, that means this import successfully done, right? Now sometimes you get error because of the date get changes when you launch the file in the Excel. So you can click on this icon, so that is going to bring you here, and you can click on this file, so that is going to show you the error. So start reading from the last. If you have any error, there will be an error box where you can read that. If it's a date issues, if it's a column length issues, so you'll be able to rectify it. Then you just need to re-update the column data types and maybe fix the date format in Excel, okay? So let's click close, and then let's see. Now we have imported to customers, right? We have imported to orders. Now if you want to see how many records we have imported, so we can just go ahead and kind of go to this and check this orders. You can just click on it. You see we have 10,000 records at the moment. Now you can also check it from here. You can just right click in it and you will see something called view and edit, and you can see first 100 rows, last 100 rows, and you can see all rows. So we want to see the first 100 rows or maybe last 100 rows, so you can just run it, or it's automatically going to run the code and it's going to give you the last 100 records, which you can see it here. These are the last 100 records of the data. So that is another way to check, or you can just right click on it and you can just click on count rows. That's also going to give you the number of rows that it has imported. Next we need riders. Now what is the reason I told you that you need to follow this hierarchy to import the data? So let's try to import into this deliveries table. We have not imported the data into riders. Let's see if we can get any error, right? So in the deliveries it's null, in the riders we have null, no records at the moment. So let's first try to import into deliveries. Let's see what is the error we get, okay? So I will select the deliveries and options, header is enabled. So let's press OK. You see I'm getting error, so it's saying immediately I'm getting an error. If you just check this, check the error, you will be able to understand here. Okay, here it's saying insert or update deliveries violates foreign key constraint FK orders detail order rider ID 1 is not present in the rider table. See, now it is trying to import in the delivery table. If you see the first record in the delivery table, the first record need a rider ID 1. So this one must be present in the rider table. So we're trying to insert a delivery record and it cannot find this rider ID 1 because we have not imported the data into the riders table. That is the reason we're getting this error. Okay, so this is how you read. You see, Now there is an error box here. I can see the error. So let's go ahead and import to riders, and then let's see if you get any issue, right? So I would say right click, import, and select, and I would select the riders. Make sure option header is enabled, press OK. You see it has imported. Now we have the riders informations. We can just check it. Let's go ahead and run it. You will see we have the riders, right? One is Rabi. So now we will try to import into deliveries. So right click and import, and we will select the deliveries, which is going to be this option. Header is enabled, general, okay. Now you see we are not getting any error. This time it has imported successfully. Let's go ahead and verify it. In the deliveries table we have now 9750 records which is imported. Okay, so this is how you import the data set using this simple approach. Okay, now if you're using MySQL, there is a chance that you will not be able to import all the records, because in MySQL you get a lot of bugs and you may experience some issues, right? So for that I will recommend you to use PostgreSQL and install this tool which is called pgadmin 4. This is very handy, and you can use the same syntax that you use in MySQL. Okay, so let's explore the data. We have imported the data. Now we have seen what is the number of records we have. So let's see if one of the data has any null values. Okay, so first I will check for this customer table. So I'm going to check the total count here. I'm just going to say count of star. That's going to return us the total number of records we have, which is 33. So let's see if we have any null values in the customer table. Now we have customers ID, which cannot have any null, so I don't have to check this column. We have customer name and registration date. We can check this two column, right? So the way I check null values, I can go ahead and say where. Okay, I would say where customer ID is null. Okay, so if there's any record that has a customer ID as null, I will have it, right? So here again that's not possible because this customer's ID is a primary key, right? So that cannot have any null records. So we can check for customer name and registration date. So we can check customer name is null. Let's see if you have any customer name is null. So no, that's great. Now let's just check for next column, which is going to be registration date. So we can say here customer name is null, or I can just say or, and I would say reg date is null. So if any of this record is null of any of the column, so I will have the result. Okay, we can see 0, so that means no null for the customer table. That's great. Now we can use the same logic for the restaurant table as well. So I will just write down here, and here I would say select count from restaurant. So that's going to be my restaurant table. I just need to write all the columns name here. Okay, so let's see what are the column name we have in the restaurant table. So in the restaurant table we have restaurant ID that cannot have any null, so I will not need to write this column name, but we have restaurant name. So we can check here restaurant name, RESTAURANT, restaurant name is null. That's one of the column. Then I want to check this city, so city is null. Then I want to check next column, which is going to be opening hours. Okay, so if that is null. Okay, so this seems like these are the only 3 columns I have. Let's see. Let me just check. Hour is null. Okay, so if there's any null, we will have it here. Okay, so seems no null for the restaurant table as well, which is great. Now I'm just going to check for the next table, which is called orders table. So that has a lot of columns, so I would just simply go ahead and say select, okay, everything from orders. Now you just unfortunately need to select all the column name manually one by one. Now order ID, I know this cannot have any null records. Now I know this customer's ID and this restaurant ID, these are foreign keys, so this cannot have been null. So only I will need to check order item, order date, time, order status, and this amount. Okay, see the most important is the amount. So we will just go ahead and say where, and I'm going to say order item is null if any. So then I want to check order date is null. The reason why we are checking null, because it's very important. If there is any null in the data set, this may give us incorrect reports later on when we will perform data analysis. So before data analysis, we must delete the null, or we must replace the null with some other numbers or values, okay, based on the data set. So order date is done. Order time, so let's check for order time. Order time, and I'm going to use a or between, so is null. Next I have this order status, or order status is null. Then I have last, which is called total amount is null. Okay, so let's kind of see if there's any null in the order table. We will have it here. So it seems like there's no null. That's great. Now I will show you by any chance if there's any null, how does it look like. Okay, so let's go ahead and insert the records in the order table, and let's see, and let's try to say that this order amount is null. Okay, so how do you identify? This function is going to identify. Okay, so I'm just going to add one null records here to show you. Okay, so I would say insert into, and I'm going to say insert into maybe this orders table. Okay, now I'll just need to define the column, which are the mandatory columns are going to be the order ID, so order ID, and customer ID, and going to be restaurant ID. So these columns are mandatory. I cannot put null on this column, but rest of the columns I can put null. Okay, so by default I do not select rest of the column. It's going to add null for the rest of the columns. I would say values. Okay, and here I will just need to add values. So let's say I will be adding 3 nulls, so I will just say, okay, 3 nulls here. Now I will need to ensure that I put on the right, customer's ID which exists in the customer table, and the right restaurant ID which exists in the restaurant table. So I'm just going to use something called maybe 9 here as a customer ID, and order ID I'm going to use it call 1002. Okay, and next I would use as a restaurant ID, that's going to be 54. Okay, so I can see this records, so I would just use 1003, use as a 10, and use as a 51. Okay, and I would say 1005 and use as a 10 and use as a 50. Okay, so these are the random restaurant name, but I know that this 54, 51 and 50 restaurant we do have, and I know this 9, 10 and this 10 does exist, right? So I can just execute this, and this is going to insert some null values. Okay, it has done, it has inserted. Now if you see, earlier it had 10,000 records. Now let's see how many records we have this order table. Okay, so this time this order table has 10,003 records, including the 3 records just we have added. So let's execute this query to see if in case it can identify the nulls. Okay, now you can see this query showing that we have 3 nulls. Okay, 3 records with all these column nulls, right? So this is how we identify. Now we can replace this with some values, or we can just delete it, right? So to delete it, you just need to write it here. You can just write it here, something called delete from, and you just need to put your where conditions. Okay, so in the where conditions, delete from this order table, and where you just need to make sure this condition is correct. Okay, so I will just close this statement here, and let's just run it. It has deleted the records. Now you can just verify it. You will not see any null at the moment. You see nulls are gone. Okay, so this is how we can identify null, and we can just delete it, or you can just replace it with update statement. Okay, so it seems like no null for the orders. Next we want to check for riders. So it's a small table, we can just check manually. Seems like no null. Okay, and for the deliveries, again it's long table, so we can check it, but it doesn't have any nulls so far. Okay, you can check it here for 1000 records, seems no null. Okay, again if you want to check it, you can just write it this way, which is the whole table into this where conditions using this or logic. Okay, so this is how we check null values. So I'm just going to add a comments here, say that checking null values. So I would say handling null values. Okay, so you have seen how you can handle with the null values. You can either delete it, or you can update it using update statement. Okay, so this is done. Now let's go ahead and start solving the 20. Put all the business problem here. Now based on the data set, you can define your own business problem. So I am just going to put the business problem that I have based on the data set, based on my analysis. I got it right. So let's go ahead and put all the business problem one by one, and then start to solve it. So here are the 20 business problem we will solve using SQL. So let's see the problems. So the first problem says write a query to find the top 5 frequently ordered dishes by customer called Arjun Mehta in the last 1 year. Okay, so let's read the question one more time. I would suggest you to read the question 2 or 3 times, or maybe more than that, till the time you don't understand what exactly you need from the question. Now the question one says, write a query to find the top 5 most frequently ordered dishes. So you need to find most 5 frequently ordered dishes by customer called Arjun Mehta. So there's a customer called Arjun Mehta, and that is in the last 1 year, right? So we need to find out top 5 ordered dishes by this customer's called Arjun Mehta, which is in last 1 year. Okay, so now we know all the tables that we have, right? In the data set we have customers table, so you can just run this customer table and you will see all the data in the customer table. So you can see in the customer table we have the customer details, and this seems like the first customer is Arjun Mehta. So this is the customers we need, and we need for this customer top 5 dishes that this customer has ordered. Now if you just go to this orders table, in the orders table we have the information about the dishes, right, which is the order item. Now from this orders we can find out each customers and the total number of dishes they have ordered, right? So if you check the ERD, so from here we can build our logic, right? So you can see that in the order table we can find out the order informations, we can find out the customer informations, we can find out the order item, which is the dishes. So that means we can do a group by the dishes, and then we can do a count on the order ID. That is how we will able to see each dishes and how many orders are done, but by a specific customer, which is called Arjun Mehta, right? To get the Arjun Mehta, which is to get the customer name, we need to join this table, this customer table and this order table. Then first we can do a group by the customer name, which is from here we will get, and then we can do a group by the customer's ID, and then we can do a group by this order item, and then we can do a count on this order ID. That is how we can solve by just doing join between these two tables, because we need the customer name. That's the reason we will need to join this customer and the order table. So let me show you what I'm talking here. So let's go to the question number 1. So let's say first I am to select everything from customers. Okay, let's see everything from the customers. We have customers ID, customer name and the registrations date. Now let's kind of see everything from the orders table. So in the orders table we will check orders. Okay, so I can check from the orders table, we have all the order informations, right? So let's go ahead and kind of solve this problem, right? So before solving this problem, I'm going to write my approach here. Okay, so that is one of the easy way to solve any challenging question or complex SQL problem. So here, as per my research, as per my analysis on this question, I got to know that my first task is that I need to do a join between these customers. So I would say join here, join customers and orders, right? I would just write my short approach. So I need to first join customers and orders. Once I have the join, I will have the customer's name and their order informations, like how many orders they have done, right? Then I can see that each customers and how many dishes and how many orders they have done in each dishes, right? So that means that I will need to do a group by customers ID or customer name. Okay, and then dishes, the second group by, and then I can do a count, right? Count of the total order ID. So that is how I will get to know each customers and how many orders they have done for each dishes. Now before that, I need to filter the data for last 1 year. You can see here it says last 1 year. So right, so I would need to filter the data for last 1 year, right? Filter the data for last 1 year. Okay, once this is done, then I will just need to select the data only for one specific customer, that's called Arjun, right? Arjun Mehta, right? So this is going to be my solutions. Now this Arjun Mehta I can just use in this filter only. So this is going to be my second filter. So I would just need to select the data only for one customer, that's called Arjun Mehta, right? So this is one of the way we can solve it. So let's go ahead and kind of start writing our query step by step. Okay, so I would first do a join between these customers and orders. So I'm just going to say select everything from orders, and I'm going to name it called O, and I would do an inner join because I need all the customers and their order information from both the tables. So I would say customers SC. Okay, now I would say on. So you see by default it is giving the auto suggestions between these two tables. So we can see that we have customers ID and customers ID of customer table and the order table. So usually you get this auto suggestions automatically. Now we can do the join and we can see the data. So we have the order ID, customers ID, restaurant ID, order item, order date, right? All the information that we need here, even this total order amount. Okay, so what we need here is that very simple columns that we need, right? So the columns that we need is the customer ID. So first I would select the customer's ID. That's going to be this one. So I can select from one of the table. So the customer's ID I can select from the customer table or maybe order table. So I would say c dot customer ID. Then I would select the customer name, because sometimes the same name can have by the two customers. So I would just select both the column, because I will do group by both the column to ensure that it doesn't give any incorrect result. Okay, so I would say c dot customer ID, c dot customer name. Okay, so these are the two columns I need. Then I will need the dishes, which is going to be the order item that will come from the order table. So that's going to be this one, order item. So I would say o dot order item. Okay, and as dishes, right? This is my dishes. Okay, then I would need to find out for each dishes inside each customer and each customer ID what is the count, right? What is the frequency? So I would just save it as total orders, right? Total orders by each customer name, and inside each dishes what is the total order. So I need to do a group by all these three categorical column. So here after the join I would simply go ahead and say here group by 1, which is my first column, 2, which is my second column, 3 as my third column. Now if you're using MySQL, this 1 2 3 is not going to work. You just need to use this column name, or you can just use some reference here. Okay, so that's going to be some alias here. So now before the group by I had to find the filter, right? Data for last 1 year, right? So here I will need to do a filter. Now here I will do a filter, because as per the order of executions, before the group by you will need to use the where conditions to filter the data. Now where conditions only you can use it after the join, because here we are doing a join and we are creating a combined table between this orders and the customers table. So using this orders and customers table, so here I would say where. Now I will do the conditions. Now what is the conditions I want to check? See, I want to check the data for last 1 year, right? So I can use this column which is called ordered date, that is coming from the ordered table. So I can simply say o dot, and I would say order date. Okay, now I will use a simple interval functions here. So you can use any extract functions or anything, but I can use the interval functions here. So where I would say where order date is greater than equals to, and I would say interval. Okay, now I would say this way, current date and interval. So interval 1 year. Okay, so I will explain what this current date returns. Okay, so if I just run this query outside to check what this current date returns, this current date is going to return the system today date. So if you just want to check, and I'm just minusing from this current date, I'm minusing interval. So what I'm minusing interval 1 year. So I would need to say current date minus interval 1 year. Okay, so I'm minusing 1 year, okay, from the current date. So that's going to be 1 year the previous date. So you can see the previous, today is the 2nd of September 2024. So it is showing the 1 year old date, right? So here I'm saying, hey, get me only those records if the order is greater than last 1 year. So this is returning 1 year, right? So this is returning a date that is the last 1 year date. So 1 year back date, 1 year old date, right? So I'm saying, hey, I only need all of these things only if the order is greater than like last 1 year. That means if the order is done after this date, that is within 1 year, okay, from this today date. So that is my one filter conditions. Now let's see what is the second filter condition. Second filter conditions, I only need the data for a customer called Arjun Mehta. Now before that, let's see all the data. Okay, let's go ahead and run it. So we have missed something here. I have missed a comma here. So let's just go ahead and run it. Now I can see we have all the customers. Okay, we have all the customers and their kind of dishes and number of time they have ordered in the last 12 months, which is last 1 year. Now we can do order by here to organize it. So I would say order by customers ID and maybe 4 in descending. Okay, so let's each customers and the dishes that they have ordered maximum time. So if you see here, the first customer is Arjun Mehta. So that customer has ordered this dish for 9 times, which is paneer butter masala, and this customer has ordered the mutton rogan josh, that's for 8 times, and masala dosa, that for 8 times, this pasta for 7 times, mutton for 7 times. Okay, So this 5 would be the 5 dishes that this customer has ordered most of the time, right? So 3 and this 2 has the same frequency, so we will use this 2, and then we will need to select this one. So these are the 5 dishes, right, this customer has ordered most of the time. So we can simply use the limit functions, so that is going to select the 5 dishes, which is going to be the 5 records. But as the 2 dish has the same number of frequency, so it is not going to be best advice. So we can use a window functions here, so to select the top 5 dishes for this customers, right? Now for that, first of all, we need to filter the data by this customer, so to eliminate rest of the customers and their dishes and their records. So I can just go ahead and say here, after this where conditions, I want to add one more conditions. Okay, so either I want so I want the data for the last 1 year, and also I want the customer name, which is coming from C dot customer name, okay, equals, I can just write Arjun Mehta. Okay, you can use the customer ID as well, so both will work fine. Now let's just run this query again. Let's see, let's just run this query again, and Mehta, okay, Arjun Mehta. Okay, so let's just run this query again. So it is going to delete all the rest of the customers. You can see this customer has done 21 different dishes this customer has ordered. This is the least ordered one, which is paneer tikka, okay, and the butter chicken. Okay, now these are the most popular one for this customers. Okay, so now we will need to select the top 5, so we can use a window functions called dense rank or rank here. So we will just give the dishes that has the highest order for this customer will get rank 1, then second highest would get rank 2, then third highest would get rank 3, or the fourth highest would get rank 4, and then we will use the rank functions to filter the top 5. Okay, so we can go ahead and say here, I would say dense rank. I'm going to use a dense rank here. Okay, and the syntax is very simple. You say dense rank, I need to say over, and over. Now inside the over, we don't need to do a partition because only we have kind of one customers at the moment. We have filtered the rest of the customers. Now here we would say order by this total order, so the highest order would get the rank 1. So order by total orders. So the total orders, I am going to use these functions because I cannot use direct alias here, because this total order is being calculated by doing this group by, so I will not be able to directly use this column here, but I can use this count functions. Okay, so total orders and descending, and I'm just going to save it as a rank. Okay, so this is going to kind of, I would just say rank. Okay, and this is going to create a rank for each dish based on the number of time they have been ordered. Okay, now you see the rank 1 has given to the dish that has the highest order, rank 2 has given to the second highest order, so we have 2 second highest. You can see it here. Now we have in the 3 we have again 2, in the 4 we have 1, in the 5 we have 1. So this are the 5 most most demanding dishes for this customers. Okay, these are the 5 records we need. Now we can simply use this column to filter it, right? We can say, hey, select everything where this rank is greater than equals less than equals to 5, right? So that is how we will get the dishes which falls in the 5 rank, right? Top 5 rank. So to do that, again, you cannot directly use this column in this filter logic here, because this is you are creating as a window using a window function. So for that you need to save this data in a subquery, and then you can use this column, or you can use this save this data in a CT. For now we'll be using a subquery, so I'm just going to kind of put this query in as parenthesis like this. Okay, and I'm just going to name it called T1. So I'm just saving this whole data in a table called T1. Okay, now from this T1 table I would select everything for now, and I would say everything from. Now usually here I put the table name, right? So now I will not put any table name, so here I put table name, right? So I will not put any table name. So I'm saying, hey, select everything from this query, because this query is creating a table called T1 from that table. Now that table has something called this rank. Okay, that column I can use to filter. So here I would say, first let me just select everything. Okay, so you can see everything is being selected. Now I will use this column which is called rank. So I would say where rank less than equals to 5. Okay, so that is how I select in the top 5 dishes for this customers, which is called Arjun. So this is how I select the top 5 dishes for this customers, which is called Arjun. So let's go ahead and run this query, and we will have only the top 5 dishes for this customers, right? You can see it here. Now if you do not need this rank, you can just select the specific column, whatever the column you need from here. So let's say we need the customer name. Okay, now you don't have to use the alias here because the join is already done. Now you have nice one table with this column name, so you can use this column name which is coming from this T1 table that is being generated using this subquery. So we will say we need the customer name, we need the dishes, okay, we need the frequency which is going to be total orders. Okay, so we need their total orders, and we don't even need the rank. Okay, so all of these things coming from this. So we have the nice clean result which you can see it here. So you can take a screenshot and you can include in your PPT along with the question. Okay, so that is along with this query, you can include this output in the PPT. Okay, so let's go ahead and kind of see the question number 2. Now let's see the question number 2. So the question number 2 says find popular time slot. So it says identify the time slot during which the most orders are being placed based on 2 hours interval. So we need to find out the best time slot which is based on 2 hour interval. Okay, so let's first see the order table. So we will need to only use one table which is called orders here. So I would say everything from orders table, and in the orders table let's see the data. So we have, there is a column called order time, right? So this table has a order time slots, so we will use this slot, right? So now we will use this column which is called order time slots, and based on this column we will need to solve this problem because we need to find out the 2 hour slot which is the most order, because we need to find out the 2 hour slot which has the most order numbers, okay, which is the most orders frequency. Now if you see, we do not have any 2 hour slots, right? So we need to create a slot based on this order time. So that means we need to create different bucket for 2 hours each bucket, and based on this order time. Okay, so this question I'm going to solve using 2 approach. So then you can see which one you want to use, okay, which one you feel easy. Okay, so let's first go ahead and say that I'm going to use a kind of this column. Okay, so that's going to be order time, and I would say based on this order time I want to create a slot. Okay, so I would simply use a case statement here. I would say case, and I would say when, then. Okay, and we just need to use a else here. So I would say else, and I would say and. Okay, so this is the logic how you create a case. So I would say when, then, else, and this case is going to create a new column. So I'm going to name it call start slot. Okay, or anything you can just name it, but for now I'm just going to name it called start slot. Let's just give some other name. Okay, so I'm just going to put everything in one line. Okay, so let's go ahead and I want to call it when, then, and okay, I will just keep it the same way. Okay, so that's my start slot. So this is going to create a start slot here. Okay, now let's kind of write some logic here. Okay, so what I want to check this time. Okay, so I want to check this time, and from this time I want to extract the hour. Okay, so I want to say hour from this order time. Okay, order time. Okay, so I would say hour from order time. Okay, I would use between and end logic here. Okay, so I want to first check if the order is between 0 to 2 p.m. Okay, so that's going to be 0 to 1. Okay, so 1 means what? It's going to be if the order is done after 0, which is after 12 a.m. and 1, so that means this 12, if in case any order that is being done after 12 to 12:59 59 minutes 59 seconds, so that hour is going to be 0. Okay, now this is how it's working. Let's say if there is an order that is being done at, let's say 12 and let's say 59. Okay, so this is the AM, right? So if the order was done at this time, if the order is done at this time, so if you use extract functions to get the hour, so you will be getting the hour as 0. Okay, so the hour is going to be 0, and so this is what I'm saying here. Okay, now if in case the order is done at maybe 1 p.m, so usually you will have something called 0. It's already going to be 0, right? 0 0 59 59, so hour is going to be 0. Now if you say there is one more order that is done at 1 p.m, so 0 1 a.m. okay, so 0 1 and I would say 59. So here if you use the extract functions you will get 0 as the hour, and here if you use the extract functions you will get 1. Okay, but if you see the slots between this and this, it's 2-hour slots, right? So this is the logic I'm going to use it here. So I'm going to say, hey, extract hour from the order time, and then I'm checking if this hour is between 0 and 1, that means between 1 to 2 a.m. If that is true, then I want to call the tracks. So I would, if that is true, then I want to call it something called 0 0. Okay, so that means starting from 0 0 to 0 0, and I would say 0 2 dot. Okay, so again this is the time, this is the time slot. Okay, now this is one of the name, so this is going to give an if this condition is true. Okay, now this is my first conditions. Let's see the second conditions, second when. Okay, so I would need to create 12 when conditions. So this is one of the long one. So here is the complete query. So you can see I'm using case statement, and I'm simply using the order time column, and based on the order time column, if I'm saying if the hour that I get from this time using this extract function, if it is between 0 and 1, that means if it is from 12 o'clock to 2 p.m, then I'm calling it which is 0 to 2 p.m. okay, which is 0 to 2 a.m. and then I'm checking the second one, if it is 2 to 4 a.m, then I'm call it 2 to 4 a.m. So this is how I'm using case statement to create these different 12 buckets based on this 2-hour time interval. Okay, and then I'm using this, and I'm just saving this column as a time slots, and then I'm using a count function, this order id, and I'm doing a group by this first, which is this case. Okay, and then I'm doing an order by this count in descending, so that I have the slots that has the highest or number of orders. Okay, so let's execute it and let's see the answer. Now I can see this slot which is 14 to 16 has the highest number of orders, that is 1188. So this is my approach 1. So let's try to solve this using an approach 2. The approach 2 is little complicated, but that is really easy if you can understand. Okay, so I'm going to say here, this time I'm going to again use select everything from orders, because the first approach will take really long time to write all this case statement. So I would say select everything from orders. Okay, let's see the table again. Now you're going to use the same column, which is order time, but this time I'm going to use a simple approach. So let's go ahead and see. First of all, based on this order time, we will create a new column. Okay, so the column I'm going to say it's something like this. Okay, so I would first of all try to find out the hour from each clock. So that is going to be same extract hour from this order time. So the same function I'm using it here. I'm saying extract hour from this order time. Okay, and then whatever that hour I get, okay, I will divide it by 2. Okay, so let me show you. I would say divide it by 2. Okay, so I'm going to divide it by 2. So this divide that I'm doing, so that is going to be floor divisions. Okay, so I would say floor, okay, and divisions. So floor divisions and divided by 2. So let me explain with an example. Let's say if the hour is 23, right? If we divide it by 2, so what is going to be the output, right? So output is going to be like 11.5, right? That's going to be the output 11.5. Now we don't need this a decimal number, right? So we will, if you do a floor divisions, by this by 2, so automatically I will just get 11, right? So it's going to kind of do a floor divisions and delete this number that is after this decimal point. Okay, so I will have 11 o'clock, which is this, right? Now this is what I will do. Okay, so I'm going to say floor extract this hour from this order time divided by 2, and I am going to multiply with 2 here. Okay, and I'm just going to save it called start time. Okay, so I'm going to explain it again what I'm doing here. So I would again say floor divisions. This time I'm just going to multiply by 2, but I would just plus 2 here. Okay, so let me kind of first run it and then I'm going to explain it here. This one I'm just going to call it end time. Okay, let's see. Now let's see what is happening here. So let me first, just to show you, I'm just going to say order time Okay, so I'm just selecting order time column, and let me just show you this 3 column. Okay, so you can see if the order time is 23, so I am dividing by 2, which is a float division, so it's going to be 11, right? Then I am multiplying with a 2, so that is going to be 22, right? Because 11 into 2, that's going to be 22, right? Then this 22 is my starting time of my bucket. Okay, the second bucket is going to be just plusing 2 with this 22, that's going to be 24. So one of my bucket is going to be 22 to 24. Okay, same way all the bucket will be created. Now I have all the 10,000 records. I don't have a specific bucket, but if I do a group by the start and end time, I will have this specific 12 buckets. So if you want to understand it here, what we are doing, we are just dividing this hour that we get, which could be the odd hour as well. So we're dividing the hour divided by 2, that is how we get the odd number. Let's say 11 o'clock, right? So that is how we get the time as 11 o'clock. Now if you multiply with 2 this 11 o'clock, so it's going to be directly 22, right? Which is the 22 hour, right? Like the 10 p.m. So this is my starting time, correct? So you see, even it was odd hour, which is 23 p.m. So we somehow end up with this starting of this 23. That's going to be, because this 23 falls in between 10 to 12, right? In the midnight, in the evening, right? So I would say this 22, and if I just do plus 2, this is going to be my end time. Okay, my starting time. So let me just explain with an example again. So let's say I have the hour as like 23 and let's say 55. Okay, 23:55 p.m. right? So this time should fall in a slot called 22 to 24, which is going to be 12 o'clock, right? So 12 a.m. So they should fall in this slot, right? Or you can say whatever you want to call it, like 11.59. okay, 0.59. okay, so let's say in this slots you want this to fall, right? So this 23 to 23:55 p.m. right? So now if from this 23:55, if I do a float division, so I would divide it by 2, so that's a float division. So I will have it what? So 23 divided by 2, that's going to be 11.5, but it's a float division, so I will just end up with something called 11, right? So 11, right? So if I multiply with 2, so that's going to be what? That's going to be automatically even number, right? So that's going to be 22, correct? So I would say this 22 as a starting of my bucket. Okay, so I would say start, this is my starting time. Now I would simply add this 22 plus 2. Okay, so that's going to be my end of the bucket. So into plus 2, that's going to be automatically like 12 a.m. midnight, right? So that is the starting, that is the end time. So each order that will go through these two conditions, and I will either, and it will find the start and the end time. So then this order is going to fall into a bucket, right? That's the start and the end time. So I will have total 12 bucket here. So I can just now go ahead and do a group by, because we want to see each bucket and what is the total number of orders, right? So I would say group by 1 and 2. So we want to do a group by this two columns, and then we want to do a count. Okay, so count of what? Count of stars or order ID, and I'm just going to name it called total orders, right? Total orders in each bucket. So I can just do a order by 3 descending. Okay, so the highest order bucket come first. So you can see I have the bucket that is, which is going to be 14 to 16, and the total orders 1188. So the result that we have got using the earlier long approach, so still the same, it's like the same, which is 2 p.m. to 16 2 p.m. to 4 p.m. 1188. And if you see it here, okay, so it's going to be same, which is 2 to 16 1188, right? So it's the same what we got earlier and what we are getting it here using both the approach. So I'm just going to save it called approach 1. okay, now I'm going to save it called approach 2. Now this video, approach 2. So now this video is going to be little long. I would request you to watch in the maybe 1 or 2 hour each day, so that you can understand the concept, right? So you can watch one day and you can do the same task, then you can do the remaining task in the second days or maybe third days. Okay, so you can divide it into 2 or 3 days to complete this project. So this is fine. Now let's see the question number 3. So the question number 3 says that order value analysis. Find the average order value per customers who has placed more than 750 orders. It's order value analysis. We need to find out the order value. So we need to find out the average order value per customers. Okay, first of all we need to find out average order value per customers who has a place more than 750 orders. So all the customers we need to find out who has done more than 750 orders, and then we need to find out their average order value, which is called AOV. So we need to return the customer name and their, again, average order value. So how many orders they have done out of the total orders, how many, what is the total revenue. Okay, so that is how we will find this average. Okay, so let's go ahead and first of all see the table that we will need. So we will solve this using only one table, which is orders, and then to get the order customer name we will need to join with the customer table. Okay, let's see if you can solve it using the first table, because we have a customer ID, so we can use this customers ID column. So what we need here, we need to find out first of all average order value per customers who has placed more than 750 orders. Okay, so first we will select the customers ID. So we'll say customer ID, and I would say average, and the order ID. Okay, so order ID, not order ID, average order value. So it's going to be total orders. So that's going to be this one, total amount, and I'm just going to name it called as AOV, average order value. Okay, now I will just need to do a group by one, because I want to do a group by each customers to see the total average order value. So let's run it and we will see average order value, which is this one, you can see by each customers. So this is based on the total purchase they have done and total number of orders they have done, right? So based on this average being calculated by SQL automatically. Okay, so we want to only select those customer who has done more than 750 orders. Now if in case you want to find out the count of orders, you can use the count functions, count of stars, or you can say count of order ID, and as you can just save it as kind of as total orders. Okay, now this is fine, you can just go ahead and run it. You see now this is returning like each customers in the AOV, which is average order value, and the total orders, correct? So I can simply use this column to kind of filter, right, the data, because we only need those customer who has done more than 750 orders. Okay, you see some customer has done only one order, some customer has done 733 orders. So let's go ahead and say having, because we will filter by these aggregated values, so we will need to use a having conditions. You cannot use a where condition, because this data that you are getting each customers, and these are the aggregated value, we need to use filter on this aggregated value. That's the reason we will use having. So I would say having, in having you cannot use the alias, so we'll say having count of this greater than 750. So that's going to only select those customers who has done more than 750 orders. That's only these three customers. Okay, so our problem is almost solved. Now we just need to get the customers name based on this customers ID. So that means we will need to join with the customers table. So if you see in the customer table and the orders table, we have customers ID in both the table as a common column. So I will simply go ahead and say join here. So here, okay, now the thing is that you cannot join here, because as per the order of executions in SQL, you can do a join here after this from conditions. Okay, so you say join customers SC, orders SO. Okay, now what is the conditions, common column between them? So you can say on, and you see customers ID of customers ID, right? So by default it is coming, so we are doing the join. So orders SO, customers as C. Okay, so after this join I need to say customers. Okay, yeah, it is already defined, customers as C. Now I would say this customers ID is coming from O or maybe C, anything is fine, that is fine. This total order is coming from O. Okay, I don't need this count of number of this total orders in the result, so I would just delete it. I need the customer's name, you can see it here, so I would say C dot customer name. Okay, I don't need the customer's ID as well, so I'm going to kind of delete this or kind of put this in a comment. Okay, so let's go ahead and see. So these are the three customers and their AOV, which is average order value. This is their average order value of the lifetime, right? So lifetime, how many orders they have done, and what is the total revenue that is being generated from these three customers. Okay, so this is how we have solved the question number 3. Now let's see the question number 4. It is high value customers. We need to find out the high value customers. It says list the customer who have spent more than 100k in total on food orders. Okay, return customers name and the customer's ID. So both the question you can solve using the same approach. So here I just need to find out the total orders instead of having the average orders. So you can say sum. Okay, and I would say lifetime high value. Okay, so I would say high VC. Okay, or maybe say total spend. Okay, total spend or revenue. Okay, so this is the total spend. So we have each customer's name and the total spend. Okay, this is what we have done, and we have done a join, so we don't need having here. Okay, so let's just run this query. First of all, we will have each customers and the total spend. So far we have here, you can see it here. Now we just need to find out the customer who has spent more than 100k. Okay, so for that you can say having, and for that you just need to use this sum greater than 100k. Okay, so that's going to be kind of, this is the 100k. Okay, let's see if we have any customers. Yes, we have some customer who has spent more than 100k. These are the 14 customers. So this was the question number 4. Let's see the question number 5. So the question number 5 says order without delivery. So write a query to find the orders that are placed but not delivered. Return each restaurant name, city, and the number of not delivered orders. Okay, so this is very critical question. You can see the business want to know each restaurant and how many orders they have not delivered so far. Now you can see this is one of the critical question because business want to see each restaurant and the number of orders that they have not delivered. Okay, so this could be any reason. Again, they may do not have the stock or they may do not have the writers. Okay, so let's go ahead and see number of orders that they have not delivered. Okay, to solve this problem we can just see the ERD. So let's see the ERD. So we have the order table here which has the order ID, which has the restaurant ID. So that means based on this restaurant ID for each order we can get the restaurant name here. Okay, so that means we need to do a join between this order and the restaurant. Now in this order table we have the order ID, and in the delivery table we have the order ID. So if any order that doesn't exist in the delivery table, that means we can call that order is not being delivered. Okay, we also have something called delivery status, and we also have something called order status. So we can check all this, so let's first do a join between this and this. Now we can solve this question using a join, or we can solve this question using a subquery as well. Let's try to solve this using a join. So I will first do a join between all these 3 table. Okay, so I would go ahead, say from, and I'm going to say order SO left join because we want everything from the order table. So I would say left join restaurant SR. Okay, so this join is done, and then I would say on condition. So the both of them have the same condition, which is a restaurant ID. So this is done. Now I can just go ahead and say select everything from this 2 table, and I will have all the columns. Okay, now we can join this query with this delivery table based on this order ID, because the order ID exists in both the table. If the order ID doesn't exist in the delivery table, that means that order is not being proceeded to the delivery table. So we can do a left join here one more time. So I would say left join. Okay, now everything from this query, and I would join with the deliveries SD, and the conditions I would say as which is going to be the same, which is order ID and the order ID. So delivery of order ID and the order of order ID. So let's now run this query. Now you can see we still have 10,000 records. Okay, now if you kind of scroll it down to the right side, so you can see we will have the delivery ID, right? So wherever the order doesn't have a delivery ID, so that means that order is not being delivered. Okay, so we can just scroll through and we can see if in case if we have any orders where we do not have a delivery ID, though we cannot see it now, but we can go ahead and kind of use the where conditions to identify. Okay, so let's say we can say where and d dot delivery ID is null. Okay, let's see how many orders doesn't have any delivery ID. So that is 250 orders. You can see 250 orders doesn't have a delivery ID because the order status is showing not fulfilled. Okay, so that means the order was not fulfilled by the restaurant. Okay, so that means 250 orders that are not being delivered. Okay, so this is one of the things. Now same question you can solve simply using a subquery. You can simply say that select everything from the orders and left join with the restaurant, because we need everything from both the table, and then you can simply go ahead and say where. Okay, where you can say o dot order ID order ID not in, and here you can say select order ID from deliveries. Okay, so this is going to give us all the orders from the deliveries table, right? So like all the orders that we have in the deliveries table, that is 9,750. Okay, Now we are from this join we are getting all this order informations where the order is not being delivered. Okay, where the order is not, where the order is being delivered, and we are just comparing with this one, and we are saying, hey, give me only those order details where the order ID doesn't exist in the delivery table. That means these are the order that are not being delivered. Okay, so this is fine. Now next what we need is that we need to find out each restaurant and the number of orders they have not delivered, right? So for that I will need the restaurant name, so which is coming from r dot restaurant ID. Okay, I need r dot restaurant name. I mean I can use the restaurant name instead of ID, restaurant name, and then I would have the count of the total order ID. Okay, so count of the the order that are not being delivered, right? So for that I can simply use count of order ID here. Okay, so I would say order ID or star anything you can use as count of not delivered orders. Okay, so I will just need to do a group by. So I just need to do a group by one. That is how I will have each restaurant and the number of orders that they have not delivered. So here I would say o dot order ID. Okay, so now you can see these are the restaurant and these are the number of order that is not being delivered. So we can just go ahead and say order by to descending. Okay, so each restaurant, and you can see their number of orders that is not being delivered. Okay, you can see it here, each restaurant and the number of order that is not being delivered. So that was the question number 5. Now let's see the question number 6. It is a restaurant revenue ranking. Okay, rank restaurant by total number of revenue, total revenue from the last 1 year. Okay, including their name, total rank, total revenue, and the rank within their city. Okay, so let's read the question again. So it says rank restaurant by their total revenue from the last year. Okay, so that means we need ranking for last 1 year. Now we need to include their name, total revenue, and the ranking within their city. So in each city we will have the own ranking. Okay, based on the total revenue of last 1 year. Okay, so this is we will solve using simple two join. So that's going to be the orders table and this restaurant table. So these are the two tables we need to join to solve this problem. So let's first go ahead and say that select everything from orders. So in the orders table, if you see, we do not have anything called city, right? So but we do have restaurant ID. Based on this restaurant ID we can get the restaurant table of restaurant name, right? So restaurants, in the restaurant table we have the restaurant name and we have the restaurant city, right? So that means this is going to work. So we just need to do a join between these two, and that is going to be our first approach. So I would say join, and I will say join order as O, and I would say join, and I would say this restaurant as R. Okay, now what is the conditions? I would say simple, which is going to be r dot restaurant ID, o dot restaurant IDs, because both the table have the restaurant ID as a common column, right? Now other than that, what I need, so I need for each city, each restaurant and their ranking based on the total revenue, right? So let's first select everything from this to join, and let's see what are the columns we have. Now you can see we have all the columns here. Okay, we have 10,000 records, all the restaurant ID along with their order details. Okay, so I need now first of all each city. So I would first select the city which is coming from the restaurant table, and then I will need the restaurant name. So that is going to be here. Let's see the restaurant name. So this is the restaurant name that's coming from our table again. So I would say r dot restaurant name. Okay, then I would need the total revenue. So sum of the total revenue, that's going to be sum of total sale, right? So this is total amount, sum of total amount that is coming from the order table. So total amount, this one I'm just going to save it called revenue. Okay, so I will need to do a group by each city and each restaurant, so that I will have inside each city, each restaurant and their total revenue, because we will need to find the ranking by each city. So I would say group by 1 and 2. So that's like city and restaurant. Then I would say order by 3 descending. So in each city I will have the restaurant that has the highest ranking. So I would say order by 1 which is city, and then I would say order by the revenue. Okay, so now you can see here in Bangalore, this is the restaurant that has the revenue which is 57,000. Okay, now if you see, this is the second highest restaurant, this is the third highest restaurant. Okay, so that is for Bangalore. So let's see if we have any other city. For Chennai, we have this restaurant and this is the highest revenue, you can see it here. Now for Delhi, this is the restaurant, this is the restaurant, and this is the number of highest revenue, you can see it here. This is the second highest, third highest, right? So each city, and we have the restaurant that has the highest revenue, right? You can see it here. Now we can simply use a rank functions here, and we can say that inside each city, the restaurant that has the highest revenue will get rank 1, then second highest will get rank 2, and third highest will get rank 3. So we can simply use a rank functions. So I am just going to say rank. Now rank goes with the over. So now here we will need to do a partitions because we want a ranking for each city, different ranking. Okay, so if I don't do a partition, if I just simply say order by this revenue, which is going to be this, I cannot use the alias, so revenue descending, and if I say ranking as rank, okay, so you will see that it's going to give the ranking. Okay, I don't need the order by now. So you see it's giving a global ranking. So the restaurant that has the highest sale, which is the highest revenue overall the entire city, all the city, that restaurant get rank 1. And you see we total have like 61 restaurant and we are getting 61 ranking. Okay, so this is the global ranking. Now we want a ranking for each city, right? Each city have their ranking based on the total revenue by each restaurant, right? So that for that we will simply do a partition here. So we will say partition by r dot city. Okay, because we are saying inside each city do a ranking inside each city. Okay, and then we are saying here order by. Okay, order by total amount. So inside each city we are doing an order by, and then we are doing the ranking. Okay, so this is going to be our local ranking. So I don't need order by here, so I will just delete it. Now I will just need to correct the syntax here. Okay, I would say partition by city and order by total amount and descending. Okay, now syntax is corrected. I will just need to say this total. Let's just quickly check. Okay, what is the spelling mistake we have? So column order total must appear in the group by. Yes, we're saying group by 1 and 2, that's correct. Then we are having the revenue, and this is the ranking, correct? So we have 1 2 2. Column 0 to total amount must appear. Why? 0 dot sum total amount. Oops. Okay, so I have not used this sum. Okay, so here I will need to use the order by this total sum. Okay, so I got deleted that. Now you can see it is going to simply do the same thing, but for each city we have a ranking. Now you can see ranking start from 1 2. So all this ranking are given in the Bangalore. So till here 12 13 14. Okay, let's see how many restaurant we have. So till here we have all the restaurant. Okay, till 20 ranking, that is from Bangalore. Okay, now the second city, so that is Chennai. For Chennai we have the ranking start from again 1. So that is called local ranking, because now the ranking is given based on the city. So inside each city, based on the revenue that has the highest revenue, based on the restaurant that has the highest revenue, that's getting rank 1. Okay, now if there are 2 highest restaurant or more than 2 restaurant that has the same revenue, they both will get the same ranking. Now we can just simply filter by this rank column, which is rank equals 1. So we can use a subquery or we can use a city. So I'm going to use a city and I'm going to say ranking table as. Okay, inside this parenthesis I need to just put all the query, and I'm going to say just move it 1 indentations to the right. Now if you use a subquery, you need to select it here. If you use a city, you will be selecting at the end. So that is the difference between this city and subquery. So I would say ranking table, and what are the things I need is, let's say, let me just show you for everything, and I would say where this rank equals 1. Okay, why I'm using this city or subquery to solve this problem? Because you see, we're using window functions, we are creating this column, so we cannot filter by this column inside this query. So that means we need to come out of this query, we need to save this query in a table using a subquery or city, then we can filter. So these are the 5 city we have, and these are the 5 restaurant which has the highest revenue. Bangalore this one, Chennai this one, Delhi this one, Hyderabad this one, and Mumbai this one. Okay, so this was the question number 6. You can see how we have solved this question number 6. Let's see now question number 7. So for this question number 7, it says most popular dish by city. So inside each city we need to find out the dish that is most popular, right? So just identify the most popular dish in each city based on the number of orders. Okay, now again, if you did see the ERD, so in the orders table we don't have anything called city, but we have the order item which is going to be our dish. Okay, now if you see the restaurant table, we have the city. Okay, so this time we need to find out each city and what is the dish that is most popular based on the total orders, right? So that means we need to do a join between this order and this restaurant table, and then we will need to do a group by the city, and inside the city we will need to do a group by, another group by this order item which is the dish, and then we will need to do a count on the order ID, so to see like what is the total number of orders, right? So let's go ahead and kind of solve this one now. So let's see the question number, that's going to be question number 7. Okay, so I think one thing we missed here, so that's going to be revenue for from the last year including. Okay, so here we just need to include the last year. So to include the last year, we can just filter it. Before doing this group by, we can just filter it based on the order date. Okay, so here we can just only select those, you know, restaurant and the orders where the data is for last year. So you can say that o dot order date, okay, greater than equals to, and you can say current date minus interval 1 year. Okay, so you have already seen how we can filter based on this current date minus interval 1 year. That's going to give us the 1 year old date. So we are just doing this, and we will have now maybe different restaurant. You can see it here. Okay, so let's run it, and we will have a different result. Okay, so we have little different name at the moment. These are the restaurant based on the last 1 year, you know, ranking. Okay, so we have just added one filter condition before the group by. All right, so let's get back to the question number 7. We need to find out the most popular dish by each city. Okay, so we will first do again join. So the join condition is going to be same, so I'm just going to copy from here. So I would say join is going to be same, so I would just use the same approach here. Okay, so what I need now from this join, if I just select everything, you will have everything again from both the table, which is going to be orders and restaurant table. So we will just need to select the city that will come from the restaurant table. You can see it here. Okay, then we will do a group by the city, and then we will do a group by this order item that will come from the order table. Then we can do a count, like how many orders we have, how many aggregated orders we have for each city and each restaurant. Okay, so that is what we will do. So I'm going to select here, call r dot city, because city is coming from the restaurant table, and I'm naming the restaurant table as r. So then what I need is in the dish, that is going to be o dot order item. So I would say o dot order item, and that's going to be dish. Okay, so next what I need a count, right? So count of order ID. So for each city, inside each city, I'm saying each order item which is dish, and the count, like the frequency, as total orders, right? Now I just need to do a group by first and 2. So I would say group by 1 and 2. Okay, so I will have each city, and I will just need to run it again. There is a syntax error. Let's just check r dot city. So from the r I'm getting city, o dot order item as dish, that's also correct. So I'm saying count of order ID as total orders. So looks everything fine. Okay, I missed a comma here. I will just need to delete that star. Now you can see each city, and we have the dish that and their total orders, right? So we just need for each city one dish that has the highest total orders, right? So for that, again, we will need to use a window functions called rank here as well, because in each city we may have multiple, you know, restaurant, and we may have multiple restaurant with the same order, total orders, right? But we want a ranking inside each city, different ranking based on the dish. Earlier based on the, you know, here earlier based on the city we got the ranking. Now here we will have the ranking based on the dish. So I can just copy this one, same thing here. Okay, but I'm just going to say here, okay, rank partitions by city instead of city. Now yes, we will do a partition by city because inside each city we want to see the ranking. So everything will remain same, but this count is going to change. Okay, this total order is going to change. Now we are saying based on the total orders we want the ranking, not the total revenue. Okay, let's see ranking. So I missed a comma here. Let's just add the comma and let's just run it again. Now you can see we have each city and the dish that is most popular. For Bengaluru is a chicken biryani, which is 172. Total orders rank is 1. Let's see the second city, which is called Chennai. So Chennai, it's a mutton rogan josh and the total orders 74 and the ranking is 1. Let's see for Delhi. So for Delhi it's paneer butter masala 97 and ranking is 1. Now let's see for Hyderabad, it's chicken biryani and the total order is 81 and the rank is 1. Okay, then let's see for Mumbai, it's paneer butter masala, that's 363 and ranking is 1. Okay, so we can just now go ahead and save this in a subquery or CTE, and then we can just filter using this rank column. This time I'm just going to use it as subquery. I'm going to name it called T1, so where rank equals 1. Okay, now if I just run this query, I will have the result. Now I want to show you, if I just use this where conditions here only inside this query, that's not going to work, because first of all this rank that you see, if I just add it here, even after this here, you see this is going to say rank doesn't exist. Okay, you see rank doesn't exist because this is not an actual column of this table, right? These two tables. That's the reason we cannot do filter inside. So that means we need to save this query and filter, go outside, then from the outside we need to do the filter. Okay, so these are the 5 city and the 5 popular dishes. Okay, so that was question number 7. So the question number 8 says customer churn. It says find the customers who haven't placed an order in the 2024 but did in 2023. So this is a complicated questions, we need to understand it. So you can read it multiple times till the time you don't understand. We need to find those customers who have not done any orders in 2024 but they have done orders in 2023. Okay, to solve this question we need to break the problem in 2 approach. So first we need to find out customers who has done orders in 2023. Okay, so the customer who has done orders in 2023. Then we need to find out customers, okay, who has done orders in 2024, who has not done. Okay, who has not done orders in 2024 but they have done orders in 2023. So we may have some customer who has not done any orders in 2024 and not done any orders in 2023. We don't want to see those customers. Okay, then we can just compare 1 and 2, okay, using a subquery. So this is what we will use. So let's first find out the customers who has done orders in 2023. So let's first go ahead and see the table. So we will say select everything from orders. So we will have the order table. Now the order table has again all the 10,000 records, you can see it here. Now we will only need to find out the orders of 2023. So we will say where, and based on this order date we will filter. We will say where order date equals 2023. right? Now order date is a date, we cannot directly compare with 2023, but we can use the extract functions. We can say extract and we can say year from order date. Okay, so that's going to give us the year from this order date and we're comparing with 2023. So we will have out of 10,000 orders, we will have 9,975 orders, that is for 2023. So most of the data are 2023 only. That's the reason you see 99, maximum percent orders are 2023. Okay, so this is giving us all the orders of 2023. Now what I need is that I need distinct customers ID, all the customers ID who has done orders, right? So I can say distinct customer ID. So all this customer has done orders in 2023. So the problem is solved. Now I need those customers who has not done any orders in 2024. Okay, so if the customer has done in order in 2024, I don't want to see those customers. Okay, so I will say this is my one of the where conditions. Okay, so this is my one of the where conditions, and I want the second conditions that is to be true, that is the customer shouldn't be purchasing anything from the 2024. So I will be using something like same approach here. So I will say and customer, and I would say customer id not in. Okay, and in the not in I'm going to use a logic called select distinct customer id. Okay, from orders. Okay, I will say where this extract order date. Okay, so this extract order date equals 2024. So this is going to give us those customer who has done purchase in 2024, right? So all this distinct customers id I will have it here. Let's check. You can see all this customer has done purchase in 2024. Okay, now I am saying in this earlier logic, if you see in this earlier logic, let me just put it one indentations here. So if you see earlier logic, I'm saying, hey, get me all the customers id who has done orders in 2024. That's great. Then I want only those customer who also fulfill this condition. What is this condition? So that means this customer shouldn't be exist in this 2024. That means what? This customer has not done any purchase. So that means this, whatever the customer's id that this query is returned, I don't want the customer's id to be here. If the customer's id to be here, that means the customer's id has done purchase in 2024 and that has done purchase in 2023. Okay, so this is going to kind of give us only those customers who has not done any purchase in 2024 but they have done any purchase in 2023. Okay, so this is what logic we're using it here. So we're using a simple subquery logic here. Okay, now if you need customers name, based on this you can simply do a join with the customers table and you will be able to get the customer name. Okay, so for now I think this kind of solve the problem. Okay, now let's go ahead and kind of solve the question number 9. So the question number 9 says calculate and compare the order cancellation rate for each restaurant between the current year and the previous year. Okay, so for each restaurant we need to find out the order cancellations rate for the current year and the last year. So first of all we need to find out what is the total orders and what is the total orders that they have cancelled in the current year for each restaurant and the last year. Okay, so for this, to solve this problem we will first see the data. So we can solve it using only orders table, but if you need to return the restaurant name then we will need to join with the restaurant table based on this restaurant id. So to make it simple, let's first see each restaurant and number of orders they have done and number of cancellations they have done. Okay, so for that I'm just going to say here that restaurant id. Okay, and count as order id. So order id, so I will just need to do a group by 1. So I will have each restaurant and the number of orders they have done. If I need it for the current year, so I can simply use say where, let's see, if I need it for last year, so I would say where extract okay year from order date equals last year, which is going to be 2023. Okay, now that's going to give me the orders, all the restaurant and their total orders for the last year, which is 2023. Okay, now I need the total cancellations rate. Right, now to get the cancellations rate I need to first find out the total number of orders that they have cancelled. Okay, so that I will be able to do a join with this deliveries table and then I will able to count how many orders they have not delivered. Okay, in the last year, which is in 2023. So for that I will do a join. So to do a join I would say order is O, and I will need to do a left join because I need every orders from the order table and then I will need every deliveries information from the delivery table. If in case the order is not being delivered, so the delivery id is going to be null. Okay, so it's a left join deliveries S and D. Okay, so restaurant id I'm getting from the order table and this order id I'm getting from the order table. Okay, now next what I want to count is the total number of orders that they have not delivered. Okay, now this is important. Okay, so if you just want to see the data, so I will just show you the data first of all using simple star, then I can explain like what I'm talking here. Okay, let's see. Let's kind of say select everything from orders, left join deliveries S D. I have not defined the on conditions. I would say on, and I would need to say O dot order id. Okay, equals D dot order id, right? So this is fine. Let's go ahead and kind of first let me show you. So I would say select star from orders as O, left join. Okay, I'm not defined even the join as well. Oops, left join. Okay, now let's kind of run it again. So we have 10,000 records. Okay, now this is, I have not filtered for 2023. Now you can see I have the 10,000 records. Okay, now I will have wherever the order is not being delivered in the delivery ID, I will have null. Now if you use a count, that is not going to count the null. Okay, now how do we count the null? Okay, I'm going to show you. Now here I'll be using case statement, and I would say if the delivery ID is null, then I would replace it with 1. Okay, so I would say case, so when d dot delivery, okay, d dot delivery ID is null, then 1. Okay, so that's going to be 1, that's what I'm saying. And else I would just leave the else and I would say end. Okay, now this end, and I'm just going to save it, call not delivered. Okay, not delivered count. Okay, so let's run this query and let's see the result. Now you can see for each restaurant we have the number of order that is being delivered, number of order that is not being delivered. Now if you want to see the logic, it's a very simple logic what we have used it here. So which is kind of, we are simply saying restaurant ID, and we are doing group by the restaurant ID so that we can see the count of total orders. Okay, that is fine. Now we are doing a left join, so we are getting all the orders from the order table, and we are getting all the deliveries from the deliveries table, where we were getting delivery ID, order ID, and everything. Any orders that is not being delivered, that doesn't exist in the delivery table, so I will have the null instead of having the delivery ID. So using this case statement, I am replacing this on delivery, where the delivery is null, I'm replacing with 1, and then I'm using simply count functions to count the total not delivered. Okay, so this is how I am kind of counting the not delivered. Here you can see 12, 10, 3. Okay, each restaurant and the not delivered of 2023. So this is returning their last year not delivered. Now if I just need current year not delivered, so that's going to be 2024. So let's kind of see. Now you can see each restaurant total orders and not delivered, so mostly they are 0. So that means if you want to find the difference, it's going to be kind of really easy, right? So because all the restaurant has 0 not delivered in this present year, which is 2024. So the question is, cancellations or rate comparisons to the last year of restaurant. Okay, current year and the last year. So let's see how we can find the cancellations or rate. Let's say the total order is, let's say 4. Let's say the total order is 4. Out of 4, there is 1 order that is being cancelled. Okay, so if you multiply 1 order that is being cancelled divided by 4, and if you multiply with 100, so you will have the cancellations rate, which is going to be 25%. Okay, so here if you see this query, which is 2023, that has each restaurant, number of orders, number of not delivered. So we just need to divide this not delivered by this total orders and multiply with 100. That is how we will have the cancellations of rate. So I can simply go ahead and kind of use it here. Now to get this cancellations, I will need to save this data in a subquery or CTE, because I will need to divide this column divided by this column. So that is going to be complicated here. So I will use a subquery or CTE here. Okay, so I'm going to say with and cancel rate, okay, as, or cancellations ratio as, and here I'm just going to save it as inside this CTE. Okay, now from this CTE I'm just going to select each restaurant ID. So I would say select, what I need is the restaurant ID. I would select each restaurant ID, what I want to select restaurant ID, and I want to select the total orders. Okay, I want to select the total not delivered. Okay, now if in case I want to find the cancellations rate, that's going to be not delivered divided by the total orders times 100. Okay, all these things I'm getting from the above CTE. Okay, so that is I'm getting from the above CTE, which is going to be cancellations ratio. Let's run it and let's see the result. So it will take some time because it will has to go through all this logic that you see in the above. Now you can see the result is showing 0 because we are getting a 0 division error because we are generating all this number using some other logic. So here we can solve it using something called numeric functions. Okay, so I will just convert this result into numeric before doing this multiplications. So I would say numeric. So this will convert the result into numeric, which is a decimal number. Okay, then I will have the percentage. Now you can see I have the cancellations ratio which is showing it here, so I will just save it as a call cancellations ratio. Okay, cancellation ratio. Okay, I will save it as a cancel ratio. So that's going to be my cancel ratio. Now if I just want to round it, I can simply use a round functions to round this result. So I would just copy it. I would say round 2 and I can put all this query. Okay, so that's going to round the result and by 2. Okay, so I will have each restaurant and their cancellations ratio for the year of 2023. Now if I need the same everything for 2024, I will just need to use the same logic here. Okay, to get the 2024. Okay, so here I will change the year to 2024. So I'm just going to kind of delete this for now. So as we do not have any cancellations rate, so the cancellations ratio is going to be 0 because all the orders are not, no order are not delivered. So that's the reason you see this not delivered and the cancellation ratio is 0. So if you want to compare it, you see we can do the comparisons. Okay, so to do the comparisons, so I'm just going to save this result in another CTE. So I would name it I would give a comma. So whatever the result I'm getting, this result I will save it another city. So I would say last year, or maybe cancel rate, or I would say last year data. Okay, you can just name it anything. Okay, and I would need to just say S, and inside the parenthesis I can just put this result, whatever I'm getting from this outcome. Now this CTE will depend on the first CTE. Okay, and I can just put it little ahead. Now this CTE will depend on the first CTE, so that is going to be dependent on this CTE. Now from this CTE I can just again join with this, right? So here I will get this result. Okay, each restaurant and their kind of cancellations rate. So here what I will do again, I'm just going to say cancellations ratio rate. Let's see, restaurant ID. I'm just going to say cancellations ratio. This one I'm just going to give a comma after this. Okay, now this one I would say comma cancellation ratio, let's say 2024. Okay, cancellation ratio is 24. So from this 24 I'm selecting restaurant ID and everything remains same. Okay, so this is going to give us the result. Now this result we will be storing in another CTE. So this one I'm going to name it call current ratio. Okay, let's see, so last year ratio, so I would say current year data. Okay, so whatever the result I get, I will store as a current year data. Okay, now to make it simple, I will just put this CTE which is on the top. Okay, I would just put this CTE before this kind of this outcome. Okay, so we have two CTE here, this cancellation ratio 24, this cancellation ratio 23. Okay, now from this 23 I am getting this result which is this one. Okay, and this current ratio I am getting it from 2024. So here I would just need to change it to 2024, cancellation ratio 2024. Okay, so cancellation ratio, so if you see it here, we have cancellation ratio 2024. Okay, now I will just need to do a join. Okay, so that is going to solve my problem. So I would say select, what I need is the restaurant ID. I can select from any of the city. I would say select restaurant ID, and then I would need the total orders of I mean, if I need the total orders, I can select it, but I only need the cancellations ratio. So I would say cancellations ratio. Okay, and one more cancellations ratio. Now I will say from. Now I will just join this cancellations ratio data. Okay, so I will need to join this current year and the last year. Okay, so I would say current year, and I would say here as join. Okay, and I would join with the last year. So last year I will have it from here. Okay, so both the table has the restaurant ID cancellations ratio and the total order total not delivered. So I am just going to say join last year. And what is the kind of common column? So both of this table has a column which is called restaurant ID. So I would simply use a alias here if in case I need, or I can simply say that current year data dot restaurant ID equals, I would say that last year data dot restaurant ID. Okay, so this is fine. Now I will just need to define it that this is I'm getting from one of the table. So I'm doing inner join, so I would just say it here, and cancellations ratio I am getting it from current year, and then I'm getting it from last year. So here I would just say last year. So this one I can just save it call current year restaurant ID. So I would just say as rest ID, the restaurant ID, and this one I'm going to save it call current year CS ratio. Okay, current year cancellations ratio, and this one I'm going to save it as last year C ratio. Okay, so let's kind of run this query. Hopefully it's going to work if there is no spelling mistake. So let's go ahead and kind of run this query. It's kind of little long, but this will work. So we have some syntax error in the select statement. Let's just check. Okay, we just need to debug it. Okay, now you can see it seems like working. So we had some bug that I have just fixed. Okay, now let's just explain everything. Okay, now you can see each restaurant ID we have cancellation ratio of their current year, which is 2024, and the cancellation ratio of the last year, which is 2023. Okay, now let's go ahead and kind of see what are the things we have done. So first you can see I am using this simple CTE where I'm storing cancellation ratio of 2023, restaurant ID, count of orders, count of total cancel using this case statement, and I'm doing a join between orders and this table which is called restaurant deliveries table for 2023. So this is how I am getting all the restaurant and their total orders and the total cancellations, total return numbers. Okay, so you can see each restaurant total orders, total not delivers, right? That is one thing. Second, I am just using the same query, but I have just changed the year to 2024. So each restaurant I have and their total orders and total not delivers. Okay, so I have now two CT. One is called cancel ratio of 2023. I have cancel ratio of 2024. Okay, now from both the CT I will just need to find out the calculations, which is this one, right? This one divided by this one, and that is how I will find the cancellations ratio. Okay, so here I'm saying last year data. In the last year data I'm saying restaurant ID, total orders not delivered, and not delivered divided by the total orders, and that's how I'm getting the cancellation ratio. I'm saving it as a last year data, and then I have this current year data. I'm just doing the same thing, but here I'm referring to the cancellation ratio of 2024. Here I'm referring to the cancellations of 2023. Okay, so all my CTE is done. So I have done so far 4 CTE. From all this 4 CTE, I am simply using normal join. So joining, I'm joining with this current year cancellation ratio and the last year cancellation ratio based on the restaurant ID. So you can see here I'm selecting restaurant ID from one of the table which is called C, that is called current year data, and then I'm saying cancellation ratio, that is from C, again that is for current year data. So then I'm saying L, which is last year cancellations ratio, that is from last year cancellations data, and I'm joining both the table based on this cancellations based on this restaurant ID in the both the table. So this query is little long, but this is how you can see we have solved it step by step. So this is returning the first year data, which is 2023, this is returning the second year data. As we couldn't do calculations between this and this, so we had to create two more city to get the cancellations data. So where we have done this and this to get the cancellations ratio data, and then we're just joining last two city, which is this and this, which has the cancellations ratio based on the restaurant ID. That is how we have solved this question. So that is the question number 9. Now let's see the question number 10. Rider average delivery time. Determine each rider's average delivery time. So for this, we can just check the riders table. So select everything from riders. So let's go ahead and see the riders table. So in the riders table, we have rider ID, rider name, and the sign up. So we need to find out the average delivery time for each riders. So that means we can just check the ERT. We have the riders table, which is this one, and we have the delivery table, this one. So that means we need to do a join between these two tables to see each riders and the average delivery time. Now to get the total delivery time, we will need to get the order time from here, which is going to be order time that is in this table, that is this one, because order time, and then we can, from the order time, we can see the delivery time, and we will able to find out the total time it took to deliver, and then we can do a group by each riders. So that is how we will able to find out the average order time, okay, in minute or maybe in hour. Okay, so that is what we will do. So let's go ahead and first do a join between the orders table. So I would say from everything from orders as O, okay, and then we will have to do a join with this deliveries table. So I would say join and deliveries as D, okay, and what is the conditions between O and D? That's going to be the order ID in both the tables. So I would say O dot order ID, and this one, let me just delete it. O dot order ID here equals, I would say, D dot order ID. Okay, so both the table have the order ID. Now we just need to find out. I can see we just have both the table order ID, customers ID, and the delivery ID as well. So we just need to find out who has delivered the product. That's going to be the rider, right? So that means we can do each group by each rider, right? And then we need to find out the time difference from the order time, which is from the order time to the delivery time, which is here. Okay, now we will not need the rider table because we don't need the rider name. If in case we need the rider name, then we can join with the rider table. So without doing one more join, we can solve the problem here. So we need to find out first of all rider ID, so each rider ID, and then we will need to find out the total time it took to deliver each product. Okay, now how do you find that time difference? So what I can do is that we can go ahead and say first of all that where the order status is delivered, right? So if the order status is delivered, then only we will want to see the count. So we will say here where D dot delivery status is not is equals delivered. Okay, so delivered. So that is how we will filter out the data where the order is not delivered. Okay, order is delivered. Okay, so that is fine. So we have each rider ID, and then we need to find out the time difference between order time and the delivery time. So we can go ahead and say O dot order time minus, okay, D dot delivery time. So I would say D dot delivery time. Okay, so this is going to give us the time difference for each order ID. So for now, let's just say order ID also I need, and I would say O dot order ID. So let's kind of go ahead and kind of run it. Now you see for each rider we have total 10,000 records, which is total 8953, which are the order that is being delivered. So each riders, and we have the time difference, but the thing is that here we have the data in interval, so you're not able to identify what is happening here, right? So how much time it took. Now if in case you want to verify it, I can also select here order time, which is going to be order time, and I can also select the delivery time. We can see the data manually. Okay, and then we see the difference. Now if you see, we are getting the order ID, order time, delivery time, rider ID, and the delivery time minus order time, and that's the time difference. But if you see here, we have the data here, but the time difference are not working correctly, because for some order time here, you see the order time for this one, which is 23 o'clock, that is 11 p.m., and the delivery time is 0, right, which is the hour. If you see, that's the 0, right? So that means here it is trying to minus from this to this, and you are getting the time difference, which is 23 hours. It's a time interval. So we need to use something epoch functions along with the case statement to deal with this type of problem. But where you will see the date, that where you will see that order time that is maybe lesser, so that's where it will work. So now here you see it's 12:22 and the delivery time, it seems to be like 17 o'clock. So here it is showing the time difference, which is again a difference time, right? So we need to solve this using something called epoch functions, which is going to get us the time difference in seconds, but we need to combine it with the case statement. Okay, so that is what I'm going to do. So I'm going to say extract, okay, epoch from. So here I will need to put my both of this time column. So I would say epoch of this and this, which is the order time minus the order time. So I would say delivery time minus the order time, and I would need to plus one condition that is called case. So I would say case, and I would say when, and I'm going to say when this delivery time is greater. So I will say case when delivery time is less than. Usually the delivery time would be greater than the order time, right? But it will be only less than when, let's say, the order time was 11:59 p.m. and the delivery time is, let's say, at 12 o'clock, right? So that's where, because it follows a 24 hours clock, so that's where the delivery time would be less than the order time. So the delivery time would be going to be 00 and maybe 15 minutes or 10 minutes, right? So I'm saying case when the delivery time is less than order time, then interval 1 day. Okay, so that means that's where considered as interval 1 day, and I'm going to say else interval 0 day. Okay, so that is what I'm going to combine with this. Okay, interval, I would say else interval 0. Okay, instead of this 0 days. Okay, now I would just need to change it in day, not days, and this one. Okay, so this is going to give me the time difference between the delivery time and the order time by considering this as well. And here I would just need to end the case, and this is going to return the data in seconds. So let me first show you. I'm going to say as time difference, okay, in second. Okay, let's go ahead and run it. So let's kind of see if there is any syntax mistakes. We have delivery time minus order time. Okay, and then we are saying case. Okay, let's just put it next line, and we're saying when the delivery time is less than the order time, then interval 1 day, and else interval 0 day. So I will just need to remove this else, and ending the case as end, and I would say as time difference in seconds. Okay, now let's run it. So we seems to have the data. Now you can see the data is in seconds, so we still don't have the correct report because this is in seconds. So we can convert into minutes. To convert into minutes, I will just need to divide this outcome divided by kind of 60. Okay, because that's going to convert the seconds into minutes. So I can just say here divided by 60 because epoch works only in seconds. Okay, so I would just run it again, and we can just verify it. Now we have the correct time difference. Now you can see here the order time was 11:59 p.m. and the delivery time was, which is 12 a.m. 11 minute. So the time difference it took, which is 11 minute. So that is correct, 11 minute 3 seconds. So for this one also you can just check again 11 minute 3 second. We can just check for some more some of like more orders. So maybe for this one, see it's 11:50 and it was delivered at 12, which is 12 a.m. for a minute, so it took 13 minutes. Okay, so for some of the data you can see it is like showing more than like the time difference. If you see, it's showing more than like 12 hours. So it could be some issues with the data, or it could be that there was some issues with the restaurant, so that's the reason it delivered really late. So that is what we can again check and fix it in other query. Now it's working for the data where we have the correct order time and the correct delivery time. So let's go ahead and now see the question number 11. So that says monthly sales growth ratio. Calculate each restaurant's growth ratio based on the total number of orders delivered since it's joining. So we need to find out each restaurant and their monthly growth ratio. Okay, so for that, let's go ahead and see the order table. So we will say select everything from orders. Now in the orders table, we have all the restaurant and their kind of total orders, and you can see order time, each and everything. So we need to find out monthly growth ratio. Okay, so each restaurant and their monthly growth ratio, what we need to find out. So for that, we will use simple approach here. We will use first of all restaurant ID, what we will use, okay, for each restaurant, and then we will need to find out their monthly growth ratio, basically for each restaurant, each month, and the total sale. First of all, what we need to find out. Now this is saying based on total number of delivered orders, okay, number of orders that is being delivered. Okay, so I would say select everything, which is select restaurant ID, took care functions to get the month number or month name. So I would say took care on this order date, so I would say took care and order date, and I would convert it into something like this, which is called YY or maybe MMYY. Okay, so this is going to be as month name. Okay, now we will just use a short name, something like this. This is going to convert this order date into this month format as a text. So this took-care function convert any date into text. Okay, so this is going to convert into text. Okay, now if you just want to check, I can just show you. Let's select everything and let's see if it's working. I would just need to select restaurant ID, okay. Now there was a typo error, let's see, comma I need to give it here. So you can see for each order ID we have the order date, right? Based on this date there is a new column that is being created called month, and that is giving the month dash year. So for, you see, the month is 8 and the year is 23, so we are just kind of creating a short column. So based on this we will do some logic, right? Because we need to find out each month and their total revenue for each restaurant since they have joined. Okay, so that is what our objective is. Now that is only for the orders where the order status is delivered. Now order status delivered, we can get it from this table, which is called deliveries table. In the delivery table we have something called delivery status. So if the delivery status is delivered, only that is what we need, right? So we will go ahead and say order SO, and we will say join. Now we will do an inner join between both the table. So I would say inner join with the deliveries as D, and I would say conditions, that is going to be O dot order ID. Both table has the order ID as a column. If you want to check, we can check, and D dot order ID. So if you see between these two tables, which is orders and the delivery table, so this order ID and the order IDs are common column between these two. Okay, so I will do the join based on these conditions, and this restaurant ID I'm getting from O table, this I'm getting from the O table. Okay, now I will just need to use a filter here. I would say where this D dot delivery status equals delivered. Okay, delivered. See, earlier I'm getting 10,000, now I will get less, so I will only get where the order is being delivered. That's 8,953 orders. Okay, so we have everything what we need. Now I can simply do a group by a restaurant ID, and then I will do a group by the month, because inside each restaurant I want to see each month and then their total number of orders, right? So calculate each restaurant's growth ratio based on the total number of delivered orders since it's joining. Okay, so that is what we need. So I will just select this, cancel this star now. Next, what I need is this count of order ID. Okay, so count of order ID as count of orders, right, which is delivered, of course. So now to get this count, I need to do a group by these two, right? So I would say group by 1n 2, right? So for each restaurant inside each month I have the total kind of delivered, right? So I would just o dot order id. So now I will have each restaurant for each month I would have the number of orders, right? So I would just need to do a here something called order by, which is called restaurant id, and inside restaurant I would need to do a order by this month. Okay, so I would say order by month, which is going to be my second column. So now for this restaurant id 1, you see the first month, the possible month, the first month, that is the January of 2023, and the total order was 35. Then you see the second month, which is Feb of 2023, 27, and the third month 43, 42, and the fourth month is again you can see it 40. Now this is how you can see each month and their total number of orders, right? So this restaurant, now if you want to see the second restaurant, we have the same thing. Second restaurant, first month total sales, second month total sales. Okay, now we need to find out monthly growth ratios. Now if you want to find the growth ratio, it's a very simple calculation. Let's say you have a restaurant and last month, which is last month, let's say you have done 20 sales. Okay, let's say this month you have done 30 sale. Okay, so this month, current month you have done, let's say 30 sale. Okay, so that means if you see last month and current month, it has increased by 50%, right? The growth ratio would be 50%. Now how do you find this growth ratio? So to find this growth ratio, you need to do a simple calculations, which is called current month sale. So current month sale minus last month sale, which is called ls, okay, divided by the ls. Okay, so this current month sale, that is going to be what, 30, last month sale, that is going to be 20, and the last month sale, that is going to be 20 times 100. So this is going to give you 50%. If you want to check, you can say 30 minus 20, that's going to be left with 10, and if you just divide 10 by 20, you will have 50% if you just multiply with 100. Okay, so this is the what we will use it here. Now how do we get the last month sale in each record? So for that we will use something called lag. Okay, so this is fine. Now I'm just going to say something called lag here, window functions lag. Now in window functions lag, I am just going to use this column, which is called count of orders. So count of orders, and I'm saying lag 1. So I need for this record, I need the previous the row result, but I don't have anything for the previous, so I will have null. Okay, so again I want it, so now I will use something called over. Now inside the over, I need to do a partition, because for each restaurant I want their own leg, right? If I don't use the partitions, I will have it here. So for here I will have the previous record, which I don't want. So each restaurant should have their own leg. So for that I would say here over, and I would say partition by what? So partition by restaurant id, which is called o dot restaurant id. Okay, so partitions of o dot restaurant id, and I would say order by what? Order by this month. Okay, so what you are doing it here, so I would say order by month. Okay, so order by month. Now that is fine. Now we can simply go ahead and say as previous month orders. Okay, so I will simply go ahead and kind of run this query now. So we cannot use this month because this month is not the actual column, so we need to use this toChar functions here inside this order by. So order by this month, which is going to be a part of toChar functions. Okay, now let's run it. Now we can see for restaurant id 1, the first month is Jan 2023. The count of orders, you can see it here, which is 35. So previous month null, because why? Because we don't have the previous row, right? Now for this you can see the current month, which is going to be 27. Okay, the previous month was 35, so you have the previous month is here, which is 35. Okay, so that means we can now do some calculations between this and this to find the growth ratio for each month, right? Now what I want to show you, the reason I have done partitions by, you can see it here. So for this restaurant id 2, so the present month, which is in Jan 23, we do not have the previous month records. 35 orders, previous month is showing null. If I don't do this partition by, if I just remove this partition by, just to show you, if I remove this partition by, so you will see I will have global lag. Okay, instead of having kind of the local lag. So let's see. Now you see here restaurant id 1111. Okay, restaurant id 2. So I am having this, for this restaurant I am not having null. Okay, so for this restaurant you can see I'm having 40. So it is getting one of the previous row result from somewhere, right? So based on the order by. So that's the reason we need to do a partitions by here. Okay, so we will do a partitions, and to kind of deal with it. So for each partitions, it is having each own leg, and based on the leg, it is getting the previous count of orders. Okay, so what I can do here is that I can save this count of orders as kind of current orders. Okay, current, okay, month orders, and this one I'm going to say previous month orders, which is, I think I have already done it. Now I'm just going to kind of run it. Okay, I have the data. So what I now need to do is that I need to find the difference between these two and divide it by this previous month sale. So that is how I will have the growth ratio ready. Now these are the column I have generated using window functions. So I will save this data in a CTO subquery, then I am going to use this column. So this time I'm just going to use a CT. I'm just going to say with, and I'm just going to name it call growth ratio, okay, as, and inside this as I'm just going to put this whole query. So that is fine. Now what I'm going to select is that from the above CTE, I will select something called this, which is called restaurant ID. Okay, that is what I would select. I would select the next, which is called month. Okay, then I would select the current month orders, and I would select the previous month order, which is before current month. Okay, now I would say from, so I am going to say from where I'm getting from this growth ratio table. Okay, so let's kind of put a comma here and let's run it. I will have the same result, then I will find the growth ratio. You see I have the same result. So current month sale, which is kind of here 35, so previous month sale doesn't exist. So here current month sale is 27, so previous month sale is 35. So that's kind of picking it from here. Okay, because we have used a leg functions on this column, that is how we are creating this previous month. Okay, so let's see for the restaurant ID 2, first month is Jan, so no previous month sale, current month is 35, so this 35 comes here, and this is how it's working, right? So we need to find the growth ratio. So the function is going to be same, that's going to be current month sale, which is current month orders, minus previous month sale, minus previous month sale, divided by the previous month sale. I will just put this into brackets. So to ensure this, calculate first, then divide by previous month sale times 100. I will just need to use some numeric functions here. Okay, so I'm going to say numeric to ensure that I don't get a divisions error, because these are the column that I have generated using some leg functions and group leg functions in the previous query. So all of this I will simply convert into numeric. Okay, now you can see I have the growth ratio for each restaurant. Okay, I will just give a nice name here, call this one where I have it growth ratio. Okay, in this column I'm going to name it call as growth ratio. Okay, monthly growth ratio basically. So I will just go ahead and run this query. So here I have each restaurant ID, their month, and this previous month sale, current month sale, and the growth ratio. Now if you want to verify it, you see earlier month it was 35, now the current month sale is 27, so that means it has a decrease, right? You can see 27% decrease. If you see 42, and it was 42 to 40, so that means only 4% decrease, still decrease. 40 to 43 it has increased, right? 43 to 31 it has decreased 30%. You can just simply see, right, from 40 orders to 31, directly 30% decrease, right? 27% decrease. Okay, I can just round this result, which is the growth ratio result, if you want. So I can simply use cut everything from here to here. Okay, and I can use a round to put this next column, and I can just use this round to functions to round the data. Okay, oops. So I'll just do round to, put it here, and it's going to round the results. Now let's go ahead and run it again. We have a nice formatted result, which is a round up, right, growth ratio. You can see it here. Now for the month where we don't have the growth ratio, if you want to hide it, you can just use a where conditions to hide it. Okay, for now I'm going to keep it. Now let's say the question number 2, let's say customer segmentations. So it says segment customers into gold, silver group based on their total spending. Compare the average order value. If the customer's total spending exceed the AOV, which is the average order value, label them as gold, otherwise label them as silver. Write a query to determine each segments and the total number of orders and the total number of revenues. Okay, so this is what we need to find out here. Okay, so let's kind of go ahead and kind of see the data. So that's going to be select everything from orders, and let's see, we have everything here. So we can solve this problem using only one table. That's kind of one of the good thing. So we have the customer's ID, and we have the order amount. Okay, so we need growth ratio. So let's read again. So it says segment customer into gold and silver group based on their total spending. Okay, so we need to find out their total spending, and if their total spending is greater than the average order value. Okay, now for the average order value, we need to find out the average order value. Okay, so if their total spending is exceed the average order value, then we want to call it gold, and then otherwise we want to call it silver. Okay, so what we need to find out is each customer's total spend. Okay, this is what we need first. Then we need AOV, which is the average order value, so the overall average order value, and then we just need to compare these two. Okay, so we have two category, one is called gold, one is called silver. Okay, so these are the things we need. And then lastly, we need to find out each category and total orders and total revenue. Okay, so this is what we need to find out. So let's see how we should solve this question step by step. Okay, so I'm going to use a very simple approach here. So I am going to say that first of all, what I need is that I want to see each data. Okay, I want to see each customers and the total number of total spend that they have done. Okay, so each customer, so I'm going to say customer ID. Okay, and I would say sum of total amount as total spend, right, or total revenue, whatever I want to call. So I would say group by one. So each customers, I have the total spend ready. Okay, that's fine. Now what I need to find out is that the AOV, which is average order value. So for that I can simply say select AVG, this total amount from orders. So what is the average order value? You can see that is 322, right? So 322, just make sure write it down, 322. Okay, so this is the average order value. Now from this table we have each customers and the total spend. Now we want to categorize these customers based on this total spend. If this total spend is more than this average, then we want to categorize this customer as gold. Okay, otherwise we want to categorize this customer as silver. So for that we can use a simple case statement. We can say case, and we can say when, and then okay, we need to say else. We need to end the case, that's called end, and I would say customer category or level, whatever you want to call it. Okay, so this is how we will build the logics. We will say when what. So here we would need to say when total sum. Okay, when this total sum is greater than this 322. Okay, 322 is the average order value. Now we can use this 322, or I can use this in a subquery. Okay, because that's going to give us the same result. Okay, so when this total sum is greater than, inside this, I am giving this whole query. So this is going to work as a subquery. And then what I want to call it, I want to call it as gold, else I want to call it this customer as silver. Okay, let's run it, and we will see the data. Let me explain what is actually happening here. Okay, so I'm saying customers ID, sum of the total orders, which I'm saving it as total spend, group by the customer's ID, which is 1. That is how I have each customers and the total spend, right? Then I'm using a case statement here. I'm saying case when the sum of the total amount, I cannot use the alias, so I'm using this column, which is sum of total amount, is greater than something. Okay, so what is this something? So this is something is a subquery. Okay, now as soon as I execute this query, so this is this is a complete query. So this complete query has an inner query. Okay, so this is the inner query. So as soon as I execute this query, SQL try to find if there is any subquery. Yes, it's a subquery. SQL will try to solve this query, and it is going to get 322. It's going to store that in the SQL memory, and now SQL knows that there is something called 322. Now SQL is going to try to execute this outer query. So it will file each customer's their total spend by doing a group by, and then it is check if this total spend is more than this 322, which SQL has saved in his memory. If that's true, then it's going to call it gold, this customer. Otherwise it's going to call that customer as a silver. Okay, so that is what we have done here. Now we just need to do a group by this category column, and then we want to do kind of the total number of orders that this customer has done and total spend, right? For total spend we can do a sum on this, and for the total number of orders we can kind of do one more count here, and then we can do the sum. Okay, so we can say count of order ID, so as total orders. Okay, and we can just run it again. So now from this result we just need to do a group by this. Okay, and then we can do a sum on this, and then we can do a sum on this. That is how we will find out each category and the total spend and the total orders. Okay, that falls. So for that I need to save this query in a city or subquery. I'm going to save it in another subquery so that it is going to be a nested subquery. So I would say select everything from. Now I will just put this query inside this parenthesis, so I'm name it called T1. Okay, so what I need from this below table is that customer category, and I need sum of this total orders. Now I need sum of this total spend. Okay, now the reason I'm using sum, because you see I have each category and multiple record, right? So I need to do a group by this again, so that I will have aggregated total sum and aggregated total orders. Okay, so now in this table I'm naming this table called T1. So I'm getting everything from this table called T1. Okay, so here I will just need to do a group by what? Group by the column which is first column. Okay, so that I have each category and their aggregated total orders and the total sum. Okay, which is the total orders. So as total orders and as total revenue. Okay, so this is how we have solved this question. So we have done double group by, you can see it here, and we have solved this problem. Okay, so now let's see, this was the question number 12. Now let's see the question number 13. Calculate each rider's total monthly earning assuming that they earn 8% of the total order amount. Okay, so for this one we will again see the schema. So in this schema we have this riders, and we have this orders, and we have this and deliveries. Okay, so we need to do join between these three tables so that we can find out each riders and the total orders and total orders amount. So that is going to be the total earning, right? So we need to find out for each month. So that means from here we need to find a month group, and then we'll need to do a group by the month. First we will do a group by the rider, then month, and then we will find the earning based on the total orders. We need to find out the 8%. So let's start solving this problem. So I'm saying select orders as O. Okay, I need to do a join which is going to be deliveries D. Okay, on I would say O dot order ID equals D dot order ID. Okay, so my join is done. Now I will need to do one more join, but I think I have the riders ID in the delivery table, so that is going to work fine for me. So we have riders ID in the delivery table, which is here. So I can just do a group by the riders ID, and then I can do a group by this order date. From the order date I can take out the month, then I can do a group by the month. Okay, for each month I want to see each riders and their total earning. So the total earning is going to be this total amount. From this amount we will need to find out 8%. Okay, so aggregated value, and from that value we will need to find out 8%. Okay, so let's go ahead and select the column that we need. So first we need rider ID, that is coming from D table, which is delivery table. Then what we need is the month column that we will create using this order date. So I would use again toChar here. So I would say toChar, and I'm going to say order date, that is coming from order table, and I'm just going to convert it into a format called mm-yy as month. Okay, so next what I need is the sum, right? So the sum of total amount. Okay, so this is going to give me the total amount. I will need to find out the 8% later on. So I would say group by 1, then 2. So I have each riders and then their kind of the total revenue, total earning for each month. Okay, so I would say order by 1 and 3. Okay, now at the moment I have each riders and the total orders revenue. Okay, so that's not their earning, so this is the revenue of the company Zomato. Okay, so let's kind of run it. Oops, there's a spelling mistake. Let's just check. So we are saying rider ID and then order date, we're converting with this. So we have the error here. We are saying group by one, so group by 1 and 2, that is fine, and group by 1 and 3, that is also fine. Order by 1 and 3 descending. Okay, but there seems to be some typo with the 1. Let's just check again. Okay, let's just check again. Okay, so we are selling select driver ID and month and the total revenue. Okay, from orders SO, join deliveries SD. So DLIVERIS, delivery spelling seems to be fine. SD, and we're saying on O dot order ID, D dot order ID. Okay, so till here it seems to be fine. Let's just run till here. So yes, we have each rider and their month and the total revenue. I'm just doing order by. Okay, I missed a by here. Oops. So let's kind of see. Each rider ID, I have month and the revenue that is generated by the business. Okay, so from here I just need to find out the 8%. Okay, so you can see for this rider, first month this is the revenue, second month this is the revenue, third month this is the revenue. Okay, each month and the revenue that is generated. Okay, so here I can again also do a order by. Inside this rider I can do a order by the month as well. So order by 2 and then order by the 3 in descending. Okay, so here this rider, this month revenue, this month revenue. Okay, now again this 3 is not going to work, but if you want you can do it. For now I'm just going to hide it. So each rider I have this month and the total revenue by the business. Now I can find 8%, right? So to find it 8%, I can just multiply 0.08%. okay, so that is going to be the riders earning. Okay, so that's going to be riders earning. Okay, that's riders monthly earning actually. Okay, so let's see for this riders for this month. So the monthly earning is $22. So if you just want to the actual value, we can say as revenue and riders earning. Okay, let's run it. Now you can see riders month and the revenue by the business and the riders, the amount riders on here. Okay, so this is how we have solved this problem, which is the question number 13. Now let's do the question number 14. It is rider rating analysis. Find the number of 5-star, 4-star and 3-star rating each rider has. How many 5-star, how many 3-star and how many 4-star rating each rider has. Rider received this rating based on the delivery time. If the orders are delivered less than 15 minutes of the order receipt time, the rider get 5-star rating. If the delivery is 15 to 20 minutes, they get 4-star rating. If the delivery is after 50 minutes, after 20 minutes, they get 3-star rating. So this is what we have. Now we need to build the logic based on these conditions, and then we need to see how many 5-star, 4-star and 3-star rating each rider has. Okay, so for this problem, let's first have a look on the ERD so that we can build our logic. Now in this ERD, we have the order table and the delivery table. We will do a join between these two, and then we will have each order ID, their delivery time and their order time. Then we can find out their difference between the delivery and order time. We also have the rider ID. So then we will just need to kind of segregate each order ID based on the delivery time. Now based on this delivery time, we can use a case statement to create 5-star, 4-star and 3-star rating for each orders. Then we just need to do a group by the riders and this rating, and then we will just do a count. Okay, so that is what we will do here. So let's go ahead and kind of first start with the join. So I'm going to say from order SO, and I'm going to say order SO, then I would do a join delivery SD. Okay, on O dot order ID, D dot delivery, D dot order ID. Okay, so it's a select everything. Now I want to ensure that if the order is not being delivered, I don't want to include that. So I would say this delivery status must be delivered. Okay, so for that I would use a where condition. I would say where delivery, okay, status equals delivered. Okay, So the delivery status is delivered, so that's going to filter out the orders which are not being delivered, because that will not have ratings, correct? So that is fine. Now next what we need is that we'll need to find out the time difference between the order time and the delivery time, okay, using the epoch functions in seconds. So I will first select the column that I need. So let's say I am going to select the column. So first I am going to select, for now I'm going to just select the order ID. Here I'm going to select order ID. Next I'm going to select this order date. I would just select maybe the order time, and I would select this delivery time, okay. So ordered ID coming from O table, and order time coming from O table, delivery time coming from D table, okay. So these are the three columns I'm selecting. I will also select the rider ID, which is coming from D table, rider ID, okay, because these are the only columns I need to solve my problem. Now I just need to find out the order time and the delivery time difference. So then we need to use case statement to create this group, okay. Now to find the difference, we will be using epoch functions that is going to give us the difference in seconds, and then we need to convert into minute, okay. So that is what we will do. So here I'm going to say extract epoch, and I would say extract epoch, the function is extract epoch from, and here I will need to put the time difference. So that's going to be here. So I'm saying extract epoch from, and here I would say delivery time is the bigger one, right? So I would say delivery time minus the order time, okay. So that is fine. Then I'm just going to divide it by 60. So this usually works, but for this one, you see this is going to be the bigger one, right? This is going to be the the order time is going to be bigger one, delivery time is going to be the smaller one. So for this one it is not going to work, so we need to combine it using the case statement. So let's first fix the the syntax error. So I'm saying extract epoch from, so this kind of minor query, okay. Then this is my extract, find, and divided by 60, okay. So I missed a comma here, so let's keep the comma. You will have the data in seconds now, but that would be really large number, so that means something is not going right, okay. So for that, because of that, I will need to use something called case statement here. So because where this order date is, usually this delivery date would be bigger and the order date would be smaller. Let's say if somebody buy at 11 p.m. and the orders delivered at 12, okay, so that means this is a 12, so 12 would be 0 as the hour and the minute is 11, right? So that means it is delivered at 11 minute and the hour here is 23. So if you minus from this to this, so you will have kind of the seconds in large number, the minute in large number, okay. You can see it here. So to fix it, we will do something called case statement. I'm going to add a case statement here along with this condition. So I would say, let's just put it here, case, and I'm saying when, and what I want to check, I would say if this delivery time, if this in delivery time, usually it's a bigger, if it's a smaller than order time, if the order time is bigger, okay. So if the order time is bigger, the same condition which we have used earlier, I would say if this delivery time is smaller than order time, okay, then I would say interval 1 day, okay, that's fine. Else I want to call it interval 0 day, that's it. I've used already this syntax in the previous question, so I would just need to say end, okay. Rest everything remains same. Let's just run it. Now you can see here we have 11 seconds, 11.3 seconds, absolutely correct. Here we have, again, there would be some issues, so it took like long time for delivering. So here you can see we are having again something else. So here 23:59, it was delivered at 12 o'clock 38, so we are getting the correct time difference, okay. So now we have the rider ID. So next what we need is that based on this column we can create that stars, okay, logic. So I'm just going to save it as call as delivery took time, delivery process time or delivery took time, because we already have a delivery column, so I would just name it differently, called delivery took time. Okay, something like this. Now I will just save it in a CTE or maybe a subquery so that it get little easy for me to use this all the columns. Okay, so I would say from where, from this below query. Okay, and I'm going to name it called T1. So this one I'm just going to move it one indentations to the right. So what I need now, I can build my logic whatever I need here. Okay, so what I need is that I need each rider ID that we will be getting from this here. So I need rider ID, and then I need kind of for each rider ID, and I need this delivery time. Okay, so delivery time what I need. Okay, now I need to build some logic based on this column which is called delivery time. Okay, so here first of all let me just print this to column. Okay, so I only need this to column. Now you see the delivery time here, we have some of the data has a right result, most of the data, some of the data has incorrect this delivery time. Again, that's not the incorrect, but the delivery time is really high due to some maybe reason, or maybe it's the follow-up restaurant. We can just kind of check that, but this is what we have. So here I'm going to use this column which is called delivery time, and I would say case, and I would say case when, then, when, then. So whenever I use kind of case statement, I try to write down the whole syntax so that I don't miss anything. Okay, because debugging takes more time. So I would say end as stars. Okay, so what is the logic? Let's just see the logic. It says if the orders are delivered less than 15 minutes, then they get 5 star. Okay, so I would say if this delivery time, so I would say if when this delivery time is less than 15. Okay, less than what, so this would be kind of in the, you can say in the number, so I would simply say less than 15 minute. Okay, delivery time less than 15 minutes, then what I want to call it, that what I want to call it is 5 star. Okay, so that's fine. The second, if this delivery time, again I will need to check if this delivery time, oops, if the delivery time, okay, now here I will not use less than 15, but I would use a between and. Okay, so between I would say 15 and 20. Okay, so now we need to understand less than 15 is not, the 15 is not included here, but here 15 and 20 is included. Okay, then what we want to call it, it's 4 star. Okay, so somebody get 4 star rating. Okay, else they get 5 star rating. Okay, so else they get 5 star rating. So we can just run this query. So each riders, for each orders we will have their rating. So riders, delivery time, and we have the rating. Now we just need to do a group by the rating, and we can count anything, maybe the star, and that is how we will have each rating and by each rider. So for that we will do a group by riders, and then we will do a group by this star for each rider, and then we can do a count on star. That's how we will get our result. Okay, so what I now need is that we need to group by this column. Okay, so which is going to be a stars column. Now I would again need to save everything in another subquery or CTE, but I'm going to again use a subquery to make it little complicated here to showcase the subquery skills. Okay, so I would again select everything from below table. What is the below table? So the below table is nothing but whatever I have here, right, as table 2. Okay, now here I am just going to move it one indentations. Okay, so just to make it more meaningful or readable, so I would select rider ID, what I'm selecting, and then I am doing a group by the stars. So stars, and then I would say count of, then I would say count of stars, right? So I can only do a group by this two, then only I can have the count, right? So I would say count of total stars. Okay, so now I just need to do a group by this two column so that I will have my result. So I would say group by 1 and 2. Now if I just run this query, okay, I will have the result. Okay, so let's run it. Now you can see for each rider we have the rating and the total stars. So for that I can simply go ahead and say order by one, so each riders, and then I want to maybe see 3 as descending. Okay, so each riders, the stars that they have the highest, we will see it here. Okay, so you can see rider 1, it has 2 stars, which is 5 star, this is the number, and 4 star, this is the number. And for rider 2 we have 5 star and 4 stars, and for rider 3 we have this. Okay, so due to some reason we are not getting the 3-star rating, so we just need to check if there's any mistake. Okay, so we are saying when the delivery took less than 15 minutes, then we are calling it 5 star. If the delivery time is between 15 and 20, then we want to call it 4 stars, else we want to call it 5 stars. So due to some reason it's not selecting the 3 stars. Okay, so they should change it to 3 stars, right? So that's what the typo error. So let's see now. Each riders we will have all the stars. So you see the highest stars they have is the 3 stars, this one. This riders has the highest, again 3 stars. So every rider seems to be having the highest, which is 3 stars. Okay, because the delivery time is taking more than 20 minutes for most of the orders. Okay, so that was the question number 14. Now let's see the question number 15. So question number 15 says analyze the order frequency per day of the week and identify the peak day of each restaurant. Okay, so let's go ahead and say select everything from orders. Now we have this order table, right? So here we will need to join with the restaurant table to get the restaurant name. So, and we have the order informations in the order table. Based on the restaurant ID and restaurant ID we can do the join. Okay, now once we do the join, we have this order date column. Based on this date column we need to find out week of the day, like Sunday, Monday, Tuesday. Okay, then we will do a group by each restaurant, and then group by each day to see each day and what is the total number of orders they are receiving, and then we will select one day for each restaurant that has the highest orders. Okay, so that is what the task is. So let's first do the join. So I would say orders as O, and I would say restaurants as R. Okay, now this join is not mandatory, but again if you want to showcase the restaurant name, so that's going to look more readable. So I would say O dot order ID and not D, so it's going to be R dot O dot restaurant ID. Okay, restaurant ID, and it's going to be R dot restaurant ID, right? So I would say R dot restaurant or SO restaurant as R. So I did not define the join. Okay, that was the problem. Now we have done the join. We have each order's information, which is 10,000 along with their restaurant name. Okay, so we can check it here. These are coming from the restaurant table. Now we just need to find out each restaurant and the week that has the highest number of the orders. Week of the day of the week, that's going to be Sunday, Monday, Tuesday. Okay, so I mean any day from the week. So for that we can use this order column, which is going to be this order date column. Based on this date we can create something called day name. Okay, so how do you do it? I'm going to show you. So first of all I am going to select this restaurant name because I need the restaurant name. So I would select it from R dot restaurant name. Okay, then I'm going to select O dot order date. Okay, then I would just maybe I would just select the order ID, O dot order ID. Okay, so just 3 columns will kind of solve the problem. Let's kind of go ahead and run it. There is a typo, let's just fix it and let's run it. So we have restaurant name, order date, and the order ID. Now based on, you see still I have the 10,000 records. So based on this order date I can create the day name. So to do that you can simply go ahead and say here, let's say I want to create a day name here. So I would say toChar functions. Okay, now the toChar is again useful for creating day name as well. So you need to put your day name column, you need to just put your date column, and you need to say here, instead of having it like YYMM, we will have it something called day. So if you just put it day, you will have the day name. Okay, now again I missed a comma here, so I'm just going to run it and we will have the day name. So you see this, based on this date it's a Wednesday, you can see it here. Based on this it's a Friday, you can verify it. Based on this it's a Saturday. Now we can just do group by this restaurant, and then group by this, and then we can see the number of orders that they are doing using a count functions on this order ID. Okay, so that is what we will do. So I'm just going to say now here is group by, and this is I'm going to save it as day. Okay, and I would say group by one, which is the restaurant name, group by which is this one. I'm going to delete it for now, so I would say comment it out, group by two, so that's kind of day name. Okay, then if I do this group by, I can have a count on this order count, right? So I would say count of this order ID as total orders. Okay, so this is how I have each day, each restaurant, each day, and the number of orders they have done. I can simply do a order by one, so I would have the data organized order by one, and then I would say 3 descending, so by this highest number first. Okay, so each restaurant one day that has the highest orders. So for this one we seems like have 2 days, that's for this restaurant. Let's see something else. For this restaurant we have 1 day. Okay, for this restaurant we have 1 day. So each restaurants we have different days where they have done highest total orders. So if any restaurant has more than 1 records and more than 2 days with the same orders, so that means we cannot use a limit here. So what I can do is that I can go ahead and say rank here, rank over. Now I will just do a partition because I want a ranking based on each restaurant. So I would say partition by what, partition by this restaurant name. Okay, and I would say order by what, so order by this this total orders in descending. So I would say order by this count of orders. I cannot use the alias, so in descending. So this is done. I'm just going to save it, call rank. Okay, so let's just run it. We have the ranking now, so I can simply go ahead and filter by rank 1, select everything rank 1, and each restaurant I will have the day that has the highest number of sale. For that I can just use a subquery called select everything from and below, which is going to be below table, and st1 where rank equals 1. So I have each restaurant and the day that has the highest rank. So this one, this Wednesday. So for this restaurant you will see it's Thursday and Tuesday. Okay, and for any other restaurant, maybe for this restaurant you see this Monday. Okay, so Monday has a rank 1. So that is how it's working. Now let's go ahead and kind of move it 1 indentations to the right. So let's run it. We have the restaurant name, day, orders, and the rare rank based on the rank, right? If you don't need the rank, you can select the specific column, whatever the column you want to select it here. For now I'm just going to keep it. Okay, so let me just save it for now so that I don't miss. Now let's see the question number 16. It says customer lifetime value, calculate the total revenue generated by each customers over their orders, right? So simple group by, we need to do each customers and then we will have their lifetime values. So we will say select everything from orders to see the data before solving the problem. Now we have this in this table we have something called customer side. We can do a group by the customers, and we can do a sum on this total orders to see each customers and their lifetime value, which is called CLV, customer lifetime value. Okay, so we will say here customer ID, customer's ID, and then we have something called sum and total amount as CLV. Okay, then I just need to do a group by 1. So I have each customers and their lifetime value. We have 24 customers and their lifetime values. You can see it here. Now if you just need the customer name, so you can do a join with customers as C and orders as O, and you can see this customers I am getting from this and this I'm getting from this. Okay, so I will again I can define it as O, I need the customer name, so I would say c dot customer name. So I will just need to do a group by 1 and 2 because 2 categorical column I have now. So join customers on conditions I have not defined, so I would say o dot customer id equals c dot customer id. Okay, let's kind of run it. Oops, let's see the syntax error. So orders as o, and okay, we have done the group by before that, so group by will come here. So that's part of SQL order of executions. Now we can see we have each customers and their CLV, which is customer lifetime value, okay, which is here. Okay, that is the number. Now let's see the question number 17. So the question number 17 says monthly sales analysis. Identify the sales trend by comparing each month total sales to the previous month total sales. Okay, so we can use this column, which is called order date, to kind of solve this problem. Okay, so let's go ahead and use this column to create a month column. Okay, so here I'm going to use the extract functions. I'm going to say extract, and I'm going to say extract year from this column called order date, and I'm going to save it called year, and then I'm going to say again extract. Here I'm going to use extract month from this order date, and that's going to be as my month column. Okay, now I have the year and month, then what I need is the total sales, right? So sum on total sale, or I think the column name is total amount, so that's going to be total amount as like total sale. Okay, so I just need to do a group by first two column, which is year and the month, then I can do count on this, which is total sale, right? Total amount. Okay, 1 and 2. So let's see. So I have each year and each month and their total sale, so I can simply go ahead and say order by 1 and 2. Okay, so I will have each month and their total sale. So first 2023 first month is Jan and their total sale, then 2022 and then the Feb and total sales. You can see this is how we are having the data. Okay, next what I need is that here I don't have the previous month sale because this is the first month, so this is going to be null here if I just use the leg functions, but here I will have the previous month sale, which is going to be this one. Okay, so that is what I am going to do. So I'm going to say here window functions leg, and in the leg I want to do on this column, which is called total sale column. Okay, so I would use this alias here. Okay, now I would say leg as 1, and I would say here over. Okay, now I need this leg functions. This is going to be global leg functions. I don't want any local leg, so I will just have one leg function starting from here. Okay, so I would simply just do order by these two. Okay, so order by 1 is the year. Okay, then I need the order by this month. Okay, so all this order by are in ascending, so order by, you can see this, and then I have the order by my month, and all these are ascending, so I would say as a rank. Okay, not rank, as a previous month sale. Okay, so this is what is done. Now let's kind of run it. I don't need the outside order by now. So I have each month and their total sale starting from 2023 Jan. Okay, so even if I delete it, it is still going to work fine. So you can see each month and their total sales. Now we can compare the year and the total sale. Okay, so this is how we have solved this question, which is monthly sales trend. Now this is the monthly trends. You can see each month total sales and the previous month total sales. Now you can find the difference. You can find out the sales up and down ratio as well, the same approach which you have discussed in the earlier questions. So that was each restaurant, this one. Okay, each restaurant and their total kind of growth ratio. Okay, so same logic you can use it, okay, over here as well. Okay, I think this was the questions. Cancellations rate, yeah, this one also logic you can apply. So let's go ahead and see the next two question. Okay, so let's see the question number 18 now, and 19 and 20. So the question number 18 says evaluate a rider efficiency by determining average and delivery time and identify those who has the lowest who has the lowest and the highest average delivery time. So for this one, we need to find out each riders and this average and delivery time, lowest delivery time and the highest delivery time. Okay, so for that we will use the table called select everything from orders. So we'll say select everything from orders, and we will also join with the delivery table. So I will say join deliveries S and D, and I would say on, and I'm just going to say O dot the order ID equals D dot order ID, because both the table has the order ID as a common column, right? So let's run this query. Let's kind of see order S. Oh, okay. Now we have kind of everything, so I'm just going to filter the data by delivery status as delivered. Okay, so I will say here where D dot delivery status equals delivered. Okay, so this is fine. Now we just need to find out each riders and their average delivery time. Okay, so you can see it here. Each rider we need to find out the average and delivery times, and we need to identify with the lowest and the highest average. Okay, so first we need to find out the average delivery time, then we can find out the lowest and highest using max and min functions. Okay, now to find out the average delivery time, we will need to again use the same epoch functions. So I'm just going to copy what we have written already earlier. So let's kind of copy that code. So I will just need to use this same interval functions here. So let's copy this epoch functions code here. Okay, so first we need to find out D dot rider ID. Okay, now we will need to find out using this extract functions we can find out the time it took to deliver the orders. Okay, so we would say time to deliver. Okay, so for each rider's time to delivers for each orders, let's just run it. We will have it for each rider's time it took to deliver that specific orders. Okay, let's go to last, which is here. Okay, now we just need to find out, we just need to do a group by this rider ID. Okay, and now if you just want to see everything, I can just show you. Okay, so let's show you all the columns, Mr. Comma. Let's just run it and to see all the columns. Okay, now here you see I have added this delivery time deliver, which is the delivery time. So what I just need to do is that I need to do a group by this delivery, this drive rider ID. So and then we can do average functions and time deliver, right? So for that we can save this table in a CTE to make it like more easy, or subquery. That's where we will able to kind of use this column, right? We need to use this time it took to deliver the orders, right, by each riders. So for that we will just go ahead and say with and new table, or you can say anything like delivery table. Okay, new table. As here I can just give this whole query inside this code, since in fact I'm going to just give you a new name, call maybe delivery. Okay, table, or I can just say maybe yeah, new table is fine. I would say new table. Okay, so from the new table I can just select the column I need. So first the column I need is the rider ID. Okay, so I would say select rider ID what I need, and then I want to see the time it took to deliver, right? So that's going to be my this time deliver. Okay, so all of this thing I'm getting from new table, which is my CTE. Okay, so that is fine. Now I just need to find out the average time deliver, right? So I would use average functions here, and that's going to give me group by, if I just do a group by, then I can just find out the average time it took for each riders. So I would do group by and group by 1, so that's going to give me each riders and the average time it took. So let's go ahead and kind of now run it. So each rider is ambitious. Why? I would say as riders ID. Okay, so there could be 2 columns with the same name. That's the reason we are having this issue. Now you can see each riders and this average time. So from this average time we need to find out minimum and the maximum average time. Okay, that was the task. Now to do that, again I need to save this data in another CTE. So to do that, I am going to just use a comma and I would just save it, call riders time and s, and I'm just going to put this query in this parenthesis. So this is going to create one of the CTE, and that CTE is going to store this informations, and from this CTE I'm just going to get my result. So what I need is the maximum average time and the minimum average time. Okay, so I can say select, okay, min of this average time. Okay, min of this average time, and I need max of this average time from this, which is called riders time. Okay, so that's it, and the question is now solved. Now this is the min and this is the max average order time in the minute. So you can see it here, we have the data in minute. Okay, now let's see the question number 19. It says track the popularity of a specific order item over time and identify the seasonal demand spikes. Okay, so we can check the order item and in which month they are having good sale. So that is what we can do here. For that we can simply use the table called orders table. So select everything from orders. We can see which product is getting good sale in which month. Okay, so that is what we can do. Now we will just create a month column based on this date, which is the order date. So I would go ahead and say based on this order date we can create a month column. Then we just need to do group by this this order item, and then we want to do a group by the month, and then we will see in each month how much sale they are getting and which month they are having more sale. Okay, so that is how we can do it, or you can just create different season as well based on the month. Okay, so we will do that. Now first let's create a month column. So for that I would just use extract function. So I would say extract month from order date. Okay, and I'm just going to save it as month. Okay, so here I have the month column. You can see it here, month columns are here, and now I can just use this month column to create different seasons, like maybe winter, summer, and maybe the spring. Okay, then we can see each season and what is the total number of orders being sold, the order, and what is the total number of orders being received for each order item. Okay, so that is what I can do. Now for do that I can save this table in a CTE, or I can just use this logic. So I will just use this logic to create a season. Okay, so I would say case, and I would say when. So here I would say when, then I would say this month. Okay, so this month I will just use this logic. I would say this month is let's say, first of all I need to build the logic in a proper way. So I would say when this month is winter, so for winter I want the month to be less than, let's say, less than 4. Okay, less than 3, less than equals to 4, or maybe less than 4. So March is also considered as winter, and that is one conditions. And then I want this again, next conditions is this should be this extract month. Now we can just build a logic proper way. Let's see, first of all I would say, let's first do with the spring. Okay, so I would say when this extract month, okay, when this extract month between, I would say between 4, which is between April to, and let's say 7. Okay, so then between 4 and 7, then we want to call it spring. Okay, spring. Okay, so that's, and then what else we can do is that for summer we can say 4 and 6, we can just have it 4 and 6. Now extract month from order date between. For summer we can say it's greater than, maybe greater than 6. Okay, and I would say less than, greater than 6. And so here when that is going to be, month is greater than 6. Okay, it has to be bigger than 6 because 6 will fall in this. And I would say, and this logic, okay, is less than, let's say 9. Okay, if that's true, then I want to call it something called maybe summer. Okay, else I want to call it what else, I want to call it winter. Okay, now here you see, if the month is between 4 and 6, it's going to call it spring automatically. If the month, here I'm saying if the month is greater than 6, okay, if it's greater than 6 and it's less than 9, okay, greater than 6 and less than 9, then it is going to call it summer. Otherwise it's going to call it winter. And I just need to close this case as end, and I would just name it called season. Okay, seasons. Okay, let's kind of see if it's working correctly. We can just able to verify it. So there is this typo error. Let's just check between spring. Okay, let's just check when this extract month from the order, extract month from the order date between 4 and 6. Then I just missed then here. Okay, I also missed then here. So to then I missed. Now it should work fine. So let's verify it. For this order date, it seems like summer. So let's see, it's August. So August should be summer, that's correct. So this is kind of 3, which is March. So that is I want to consider in winter, that's fine. This is 8, summer. So we can just check something else, maybe this one, which is 7, it's considered as summer, that's perfect. So for 4, it's considered as spring, that is perfect. For 11, it's considered as winter. For 2, it's considered as winter. So it seems to be it's working fine. Now we just need to do a group by this winter, which is this season. Now we just need to do a group by this season, and then we need to do a group by this order item, and so that we can see each order item for each season and the number of orders that we have received. For that I am just going to use subquery here. So I'm going to say subquery or city, I can use both. So I would say subquery select. Now what I want to select is going to be from this table, below table. So I want to select is the seasons, and each season I want to see the sales. So first I want to select the order item. Okay, order item, and I want to seasons, and I would say count of star or count of order ID as total. So let's go ahead and put this table in a parenthesis now. So I would say here T1, let's kind of put it in the parenthesis. Okay, now what I need is that I need to do a group by season and group by 1 and 2. So that's group by order ID and the season, so that I can have the total count. Okay, so let's go ahead and do that. Let's see what we have issue here. See if this is working. So this is working fine. We have the order ID, we have the seasons, we have the count of orders as total orders, and we have group by 1 and 2. Seems to be fine. Let's just kind of run it again. Group by 1 and 2. So I have missed by here. It should be group by. Now I can see each order item, and not order ID, it should be order item, So we will have each order item name and their each season and the number of orders they have done. Okay, so we can do also order by here, order by 1. So that means order by each order item and 3 in descending. So let's see. Now you can see for a burger, so it seems the winter is where we have the highest sale. So for chicken, butter chicken, so it seems also winter. And for we can also check for something else, maybe chole bhature also winter. So for egg curry also winter. So again, most of the things seems to be winter. So again, that's based on the data that what we have. And so maybe in winter we have the largest number of sales, and maybe summer we have less number of sales. So that could be one of the reason, but otherwise this query is returning the correct answer. Okay, so for pizza it's a winter. Okay, for palm masala it's a winter, so it's a possibility that in winter we have the highest sale. Now let's see the question number 20, which is going to be the last question of this project. Now it says rank each city based on the total revenue for the last year 2023. So it is going to be very simple solutions here. So I would just simply select everything from orders table, because we will need to join the orders and the restaurant table to get the city name. If you see this schemas, in this schemas you will see the name of the cities that is available in this restaurant table, and here we have the order table. Okay, so we will just go ahead and say here. So we will go ahead and say first of all orders as O to make a join, and then we will do a join with restaurants as R, and we can simply say on, and we can say O dot order ID equals R dot, we will do a join with the restaurant ID. So I would say O dot restaurants ID, and I would say R dot restaurant ID. Okay, so once you do the join, we will have everything from both the table. Then we can just see each city and their ranking, right? So for that we need to do a group by each city, and then we will do a sum on this total amount. Okay, so each city group by sum on this total amount, then we can use the window functions to create a ranking. Okay, so we can say city that's coming from the restaurant table, and I'm going to say sum on this total amount as total revenue, and I will just need to do a group by here, group by 1. So I will have each city and their total revenue. Now we can simply use the window functions to assign some ranking here. Okay, so it's going to be rank, and I would say order, and I would say over, and I would say order by this total revenue. So that's going to be sum, and I would say as cities rank. Okay, so let's go ahead and say in descending, because the city that has the highest sale that will get the rank 1, and then the second highest sale rank 2, third highest sale rank 3, so on. Okay, so this is how we have solved all this 20 question. Now this will be the end of reports. Now I'm going to show you how you can publish this project in your GitHub. To publish this project in your GitHub, just you need to go to your GitHub repository. You can just click on your GitHub repository, or you can simply go to Google and just type GitHub. And if you have not signed up, you can just click on this and you can sign up using your Google account. Once you sign up, you will have your profile. You can just click on your profile icon, and from here you can just set up your profile. And once you set up your profile, you can go to this repository, and from here you can just click on something called new. And once you click on new, you can just give a name. So for, let's say for me, I want to name it called Zomato SQL project. Okay, now I can just keep it public or private. For public, it's going to be accessible by everyone, which is recommended. Now you can keep it public if you only want to access, right? So for me, I am going to keep it private for now, and I would just click on add a readme, and then I would click on create repository. So that's going to create a repository. So here I will just need to click on edit, and here I can simply update the readme file. So if you just put one dash like this, this one hash. So that means this is a heading. So here you can say Zomato SQL project. Okay, so that is going to kind of make this line as a heading. You can see now I have already written this readme file, which you can simply copy paste. So once you copy paste, so once you paste the readme file, you will have nicely formatted the readme file where you can modify the question that you want to solve. And if you solve some other question, you can include your queries. You will have nicely formatted readme like this. So here if you want to add an image, so you can use a HTML tag. So you can just click on this edit, and you can use a HTML tag to add an image. So let me just show you how to add an image. So I will just click on add. See, I'm inside this project file. I will click on add, and let's say I want to update the ERD, right? So which is going to be this one. Okay, so I'm just uploading a file in this repository, which I will be including as a image, right? So this is done. I will just click on it, and I will just need to copy this GitHub link, and you can see this is now copied. So what I will do, I'll go back to the readme, and to edit image, so I would just click on this readme edit. So here I can simply edit maybe here. Okay, so to edit, you just need to say this simply square brackets, and inside this parenthesis you can just put the link. Okay, now you can just give any name, call ERT. Okay, let's kind of save it, and you will see this ERD which is formatted, right? So this is the ERD, the database of the project. Okay, now all of these queries that you can see it here, if you want to add any other queries, you can just right click, edit the questions, and add the queries. Whatever the problem you will solve, you can edit. You can also add your codes, and you can also add your data set in this folder to showcase your work, right? So then I can also modify all of this question and all of these solutions. At the end, you can also modify this conclusion. You can also modify this and notice each and everything by simply clicking on edit. You can also upload your SQL queries. Now if you have purchased the dataset, you must have also received this PPT which you can edit, and you can add your question, and you can add a screenshot of your solutions like this. So this is how you can explain what you have done in the projects, and you can publish this readme as well, and you can publish this PPT as well in your GitHub repository. That's it for this video. Thank you so much for watching the video till the end. If you really like this type of content, do subscribe to my YouTube channel, and you can share your thought in the comment box. Have a good day. Take care. Bye bye.